Hello everyone, this is Rupesh and you are watching CPP Net's video series on C++ STL series topic, and this is the first video on STL series and this is going to be the introduction part. So I will be discussing what STL is. So if someone asks you what do you mean by STL and all that, so you can actually give the answer to them. Okay, so it is not a very big thing. Its full form is standard template library, and yeah, you should be knowing a little bit about the template in C++ in order to understand this little better. And you should not be the master in template, because we are going to use template inside or whenever we are using STL, but we are not going to create STL. Okay, we're just going to use it. So a basic understanding of template is required, and that you can get from my video if you search. So the main part is these three things. It consists of three components. They are container, iterator, and algorithm. And I see so many people find it so hard to actually understand this, but it is really very easy. See, if you are creating a library, what you need, or if you understand it like this, let's suppose you have one data. Okay, let's suppose 1, 2, 3, and 4. This is your data. So what you want to do with this data? First, you want to store it, right? So that you can perform some operation on it, correct? So to store the data, you have the container. Okay, until unless you store your data, you cannot process it. So you have container for that. Iterator, another thing is iterator. Now once you have stored this data, let's suppose in an array, you have this array and you stored it, or there can be an linked list. Let's suppose you have linked list, you stored the data inside linked list, correct? And this is pointing to this one, this is pointing to this one, this is pointing to this one, and this is null. Okay, so this is actually a list and this is nothing but an array. So these two things, list and array, comes under container, because you are storing your data in this fashion. Okay, now where comes the iterator? Iterator is another component which helps your library to actually move on this container. So can you see this? If you have this linked list, how can you move on this linked list? In this direction only. You cannot come back because it is not doubly linked list. So iterator for this particular container would be different than iterator for array, because in array you need random access iterator. Okay, in this array, let's suppose the name is A, then you may be, or actually you would be able to access 0th location. Sometime you would be able to access. So what is the mode of the iterator here? You can directly jump at any location. So the iterator would be random access iterator or something, because there are so many iterators and we don't need to know every iterator, because we mostly won't be touching this iterator part. Okay, it's kind of an internal. Actually we need iterator whenever we have some specific requirement, like we have to implement our own container, and then for that we need some specific iterator. Then we can modify the existing iterator and actually we can reuse, and all those things are available. But we are not talking about that. We are just here to understand the three things: container, iterator, and algorithm. So you might have got the fair idea that in array you will directly jump to this location by giving this, and in list you will have to traverse on each and every node. So can you see the iterator is different here than this iterator? Yes, it is different. If you want to go to this location in array, you will directly jump by giving this syntax. But in list, you have to actually jump, and then you will finally reach. So this iterator is different than this iterator. So iterator means you will move back and forward on your container, and that facility is given by iterator. So firstly, okay, let's start with the beginning. Container will store the data. So list, array, and all those things are container. Like you might be aware of the vector. So this is also a very famous container. So this is container. You have stored the data. Now you want to iterate. You want to move back and forward on the data list or array or vector, correct? So in that case, iterator will help you to move here and there. Now there is third thing called algorithm, and this is a very general algorithms already implemented in STL library. And this can be sorting and searching, reversing. There are so many things. So you might be looking for some data in your container, then you will go for search library. Search is here, search library. And if you want to sort it, you will go for sorting library. You want to reverse something, you will go for reverse library. So can you see this? If you will add this one and this one, it is a complete library. You have the container, you have the iterator, you have the algorithm. So you can store the data, you can iterate on the data, and then you can apply some general algorithms what is available in this library. So this is what the STL library is. So don't forget to hit the like button, guys, and I hope to see you in other videos. Thanks for watching, and in other videos series I will show you all the containers and algorithms, and also this is going to be a full list on STL. And if you want the link for this full series, you go and check in the description, you will get it. So thanks for watching. I hope to see you in next videos. Bye bye. Hello. This is Rupesh and you're watching CPP Nerds video series on C++ STL topic. And this is std array, and this is a container like a standard vector. So you might have seen standard vector because people start using containers with vectors nowadays. But don't underestimate the power of this standard array. And you know what? When I started using STL and I saw that, okay, there is something called a standard array also, then first question came in my mind was, what is the need of this? Because we already have a C style array, right? Something like this. So integer array of 5 size. So what was the problem in this? Actually, there was no problem in this, but in advanced C++, we have much more than this. So watch this video till the end and you will enjoy it, I'm sure. So the syntax is like this: standard or std array. This T is a type. So if you want to create an array of integer, then you will have to write it like this: std colon array, and then you have to give integer here, comma, what is the size? Let's suppose you want to create it as like 5 elements, then array name. That's it. So this is a declaration of standard array. So this is a type and this is the size. Okay, TNN. If you know template, it will be very easy for you to understand this, but don't worry about if you don't know that. So I have noted down some points for you. So the first point is std array is a container that encapsulates fixed size array. So I have explained in my previous video, yes, this is a full STL video series and this video is one of them, and you will get the link in the description field for that full list so that you can go inside that full list and watch whatever video you want. So in previous video, I talked about containers. So containers will contain the values. They are just the containers like vector, map, set, all these things are containers. So std array is a container that encapsulates fixed size array. So what it technically means is it is an class. This array, this is a class. So it is something like this: class, and then array, okay, and then curly braces. Here we have type, and let's suppose there is some array data member inside this, and this is your n, okay, and all the member functions will come here and so many other stuff. This is just for the understanding, and if you know template, then you will be writing template and type name and all that, and after the type name you will pass t comma n here, right, in templates. So as you saw that integer is going inside t, so this integer will get replaced with this placeholder and this n will get replaced with this placeholder. Something like this should be happening, okay, not exactly this, but something like this. So now if you will see that std array integer 5 arr, now this is an object of this class, and internally this object contains an array, and you don't need to know about this particular array because you have all the interface to change this array, to initialize, assign, and all those stuff can be done using the member functions provided by this class. Okay, so let's move forward. array size is needed at the compile time. Yes, this is very important point actually, that's why I have included it. If you remember in C style array, sometime we were doing like this, integer array of n, okay? And here C in, you will get this array size. So user can give the input what should be the size of the array, okay, at runtime, not the compile time. So if you're using C in and you can take the input in n, then whatever user have given, suppose sometime user will give 5, so then array size will become 5, then sometime it can give 10, then it will become 10. But that facility is not available in this. So that's why I have included this point. Array size is needed at the compile time. So whatever this 5 is, it is actually needed. This placeholder cannot be empty at the compile time. And after that, assign by value is actually by value. This is kind of a funny, but I will answer this comment in later point of time, or let's discuss now itself. I'll just undo all these things. So we were discussing about this assign by value is actually by value. What I mean to say is, let's suppose you have this something like this. So you have this array of 5 size of type integer, and let's suppose you have initialized, forget about this semicolon, with this 1, 2, 3, 4, 5. Okay, so this is also possible with this. We'll discuss all these things here. And let's suppose you want to pass this array into some function. So this is some function and you are passing this ARR. Now, if you can recall the C style array, if you're passing something like this array, which is of C style array, then the pointer of that array would go to that function. So let's write that function here. And let's suppose you are having the array here. So this array will come here. But if it is traditional array, you will get the pointer of this array, whatever you have here. Okay, so you was actually not making any copy, you was actually passing the pointer. And there was one issue that if you want to get the size of this array, which is of this type, then it was a big problem for you. But in this, you can actually get the size of this array. If you are passing this array for now, then you can get the size of this array using arr.size function. Because this is an object and we have this size member function for this. But in case of this traditional array, this facility was actually not possible until unless you pass some another parameter which says the size of the array, what you are passing in. Or there was another way also, if you would send a traditional array with reference, then actually it won't decay. One more point. If you are passing the traditional array in one function and that function is received as pointer, then there is a decay that you are losing the information of the sizes and all that. Okay, you're just getting the pointer of that memory area and you lose the actual information. So this is called a decay. Okay, so this is just a side note for you. Okay then, so this assign by value is actually assigned by value. So yeah, as I said, if you will pass this array, then here you will get the copy of this array. Okay, so whatever you will change in this function on this array would not reflect on this array. Okay, I mean this array, because you have the copy. So you might be aware of pass by value and pass by reference, pass by pointer and all that stuff. So this is actually pass by value, and this is possible using std array, not the traditional array. Okay, so let's move to the access elements. So there are 4 to 5 ways you can actually access the elements inside the array. So let's suppose you have 1 2 3 4 5 elements inside your array, then there is this .at. You can just simply do something like cout and this array object .at, and you can say, okay, give me third number. So it is a 0 base index, so you will get this 4, okay, as output. And you have this traditional way of accessing the array, so you can actually do this. So cout, this operator, and then array, and this is also possible. Okay, this means you are actually copying from top. Okay, school days. So now you might be thinking that why we have an extra function when we can overload this operator. Yeah, this is overloaded operator. So you might be thinking why we have two similar thing. Actually, it is not similar. First one is a bound safe. I mean, let's suppose you have this array of 5 size. What if you want to get 6th element or 7th element? You cannot get it, right? Because you don't have it. So this dot at will throw an exception called out of bound. Yes, we have something called out of bound exception, and this will throw that exception, but this will not throw any exception. Okay, so we have discussed this one, and now front. So as you are using array dot at here, you can use array dot front, then it will give you the first element, and if you are using back, then it will give you the last element. Okay, and this data is a very important thing. Actually, it gives the access to the underlying array. You remember I told you that there is a class which I rubbed here. It was holding an array. This dot data, I mean, if you have this array, this one, and arr dot data, if you are doing this, then it will actually return the pointer of that array. Okay, so internal array was there, and you can get the address of that array. So it's up to you whether you want to use that underlying array in some way, then actually you can do that. Okay, so we have discussed all the points, so let's go for this one. It is the declaration. So you have to give the size, I have already talked here, and you give the type. This cannot be empty, this cannot be empty. Okay, so both are mandatory, and this can be any type, like user defined data type and all the integral, float, whatever type you can actually give here, because you can store anything in the array, right? Just give the size and type. So this is kind of a declaration. This is the initialization. You have this, my array is equal to 1 2 3 4 5. You can use this way to initialize it. This is called initializer list, and there is another way to initialize. This is called uniform initialization. I have not given the video for this, I guess. I'm not sure, but this is a new way to actually initialize in C++, and this is called uniform initialization. So let's move to the next point. So I'll just scroll it a bit, and there you go. Assign using initializer list. Yes, this is a very important point, guys. Don't miss this. It is saying that assign using initializer list. Actually, you have declared the array like this, and then using this initializer list technique, you can actually initialize your array. And you remember in traditional C style array, this facility was not there. What I mean to say is this facility was not there. Integer array of size 5, and then later in second line you are initializing or assigning your array. No, you have to give this portion after this with this equal. What I mean is something like this. But here actually you can do this also. And there are so many member functions available inside this array class, and you should actually go and check that, because this is not the video about how to use it, it is about what it is. Okay, so there is one important function which is called dot fill, which is called fill. So we can use that function if you want to assign some typical value or a single value to all the elements. What I mean to say is, let's suppose you have done this, and what you want to initialize inside this array, let's suppose 10, and all the 5 places you should have 10, then you can just simply do something like this. After this line, my array dot fill, and this is a function, you just pass 10, it will do the job. Okay, so there are so many things like this available inside this array member functions. You can sort the array just simply passing this array inside a sort algorithm that we'll talk little later in this video series, because that is a algorithm. So we have 3 things: container, iterator, and algorithm. So right now I'm talking about the container. We will talk about the iterator and algorithm in later point of time. So did you like the video? Don't forget to hit the like button and give the comment that what did you like about this video and what you didn't like about this video, or just simply good or bad will do the job. Okay, and after this video we'll go for std vector. So we'll talk about some internals about the vector, and it is going to be a lot of fun. So see you in the next videos. Bye bye. Hello guys, this is Rupesh and you're watching CVP Nerds video series on STL topics, and this is a standard vector. And yesterday we saw a standard array, and we actually came to know that, okay, why and what was the reason behind actually including the array, a standard array, when there was already a C style array. So yesterday we actually understood that. Now today's topic is standard vector, and why it is called vector. First of the question should be this, correct? So there are so many discussions why people called this vector Actually, it should have been something like a dynamic array. If someone already know this, they will be able to understand why I'm saying like this, or an array list, because actually it is a combination of array plus list. We'll talk all those things, and the main funda behind this video is we will try to understand why people actually bought this vector and how this one works internally. Okay, and we will see this pushback mechanism which you might already be knowing, and rest of the modifiers and all these things we will cover up in later coming videos, because I don't want to stretch this introduction and how actually vector came into the picture video combined with these things, because they are just the topping on the actual cake. Okay, so this is the actual cake. Maybe you don't need all these things, but sometimes we need it. So I decided that I'll create separate videos for all these. So let's start. So this is the second container inside this STL series list, which is called standard vector, and the syntax of standard vector is std : vector, and then you have to give the type here. Okay, so this can be integer, character, whatever, user defined type and all. So this is the syntax, and then just the name of the vector, let's call it vector. Okay, so this is the syntax for creating a vector. So let's look at the first point. The first point is std vector is a sequence container and also known as dynamic array or array list. Okay, so first let's see what is sequence container. Sequence container means whatever the values you will give inside this vector will be stored sequentially. It is not going to be stored random places. Okay, so it's like one after another. So that's called sequence container. Okay, now let's come to this dynamic array or array list. Okay, so tell me, what is the best part of the array and what is the best part of the linked list? I mean, why you will go for array sometime, not for the linked list, but sometime you actually go for the linked list, not the array. So what is the actual use cases of these two? The reason behind using one over the other is, let's suppose if you are choosing an array, then you need fast access because you have this operator, right? Let's suppose you have ARR, then you have this operator here. You can give any number 1, 2, 5. Let's give 5. So it will actually fetch the fifth element from the array and it will give it to you. Okay, so you can modify, you can place anything on that, and you can print it or do whatever you want. But this operation is order of 1. So this will actually fetch the memory, fetch the data from the memory in order of 1. It will just directly go and get that element and give it to you. It is not going to traverse or anything which is actually happening in the list. So, okay, so array are used for faster access. First and most important reason for array. So let's write array. And second reason for array would be, let's suppose you already know the size of your data. You're always going to have some size, let's suppose 0 to n, and you already know this n. Then it is obviously a good option to go for array, not for the linked list. Okay, because anyway you're going to get faster results. You will directly get the elements, you can insert the data inside this, you can retrieve the data from this, so this is good. But there are some places where you will go for linked list. And what is that? When you don't know the size, that time you actually go for the linked list. So you don't have to waste too much size. Let's suppose you are constructing a tree. Okay, so let's suppose initially you started constructing the tree, then it can grow at any depth, right? So you don't know what or how many elements you have to store in the tree. So you cannot go for the array because array was fixed in size, correct? If you have created an array of 5 size or 10 size, later point of time you cannot change that. But in linked list you can change it. You just have to insert the element in the array, in the list. Okay, so in the list, let me write that in list data can grow dynamically. Okay, so dynamically, and in array you have fast access. Okay, so people thought that whoever created this vector or array list or dynamic array, they thought that why not we should include fast access and dynamic thing together. They should add these two features and create another thing that came out as correct vector. So vector provides you order of 1 array access time, and vector provides you that array can grow and shrink whenever you want. So you guys must be familiar with the pushback. So let me explain you the use case of this, then we will talk about other things. Okay, so let's suppose you have a vector type integer and this is your vector. Now using pushback, VEC pushback function, you already might be knowing this. Let's suppose you are pushing 10 inside this. So as I said, this vector is a class, so let's make it class vector, and this vector is holding an array. Okay, so when you created this, you didn't give any size and all that. So let's suppose this array was not there at all. There was zero array. I mean, the size of the array was 0. There was no array. Okay, the moment you push 10, the array was created and 10 was actually inserted in the first place. And when this array was created, double of the size what it already have. So before it was 0 size, right? So now you are going to insert 1, so the size would be 1. So if next time if you're inserting, let's suppose you're doing the same operation and inserting 20 here, then in that case there is no place to actually insert that, right? So in this case only, what it will do, it will create an array. It will create an array of 2 size, at least size 2, size 3. That initial number is actually dependent on the compiler. Like let's suppose this array created 3 size array and inserted 10 inside this. So next time you're saying that, okay, push back 20, it will push here. Okay, still it is, I mean 1 is empty. Let's suppose next time you're saying that push back 30, then 30 will come here. Still there is no issue, but let me tell you that when you will insert 40, there is no place. And as I said, this vector is a dynamic array. It will change its size dynamically. So how the dynamic thing will happen, now you have to understand that. So as this 40 cannot be accommodated here, what this vector will do, actually it will create the double size of this one. Yes, you heard me correct. It will create 6th, so 0 to 5, and 10 will come here, 20 will come here, 30 will come here. Okay, and this array will be discarded. So let's suppose inside this vector class, this ARR was actually before pointing to this memory location and this array. Now it is not pointing there, it will start pointing here. Okay, so how it worked, when there is no capacity to hold a new value, what it will do, it will make the double size of already created array and copy all these elements into that. Just copy. Okay, it is just simple copy, and then it will insert this new one into this. And similarly, if you will insert the 7th element which it cannot hold, then it will create a double array. Yes, now it is 0 to 5, 6, then it will create a 12 size array, 0 to 11, and all these value will go to this one, and then you will start inserting new element in this. So this is how actually it works, and I have created a very big video on this, like how it works by examples and all. I can actually show you those examples in my video. Actually I have created that already. So if you want to see my video, you just YouTube that how vector works internally in C++. You will get it. Okay, so I have shown all the outputs and all that, but you might have got the idea by this, right? So now you know how actually the vector works internally, how it will grow the size of the array depending on how many elements you are inserting it. Okay, so this is the hidden story behind this dynamic array or the array list. Now let's move to this video and quickly complete this. So don't go anywhere, I'll quickly complete this. So the element access, yeah, if you have vector of some size, okay, just before going all these things, we will discuss this. So the declaration involves this one. You can have empty declaration, you can have a declaration of range based, like you will give the size. So this is size place and this is value place. So you're saying that create a vector of 5 size initially and put 20 in all the places. This is what it is. And another one is initializer list. This will initialize this vector with 1, 2, 3, 4, 5, and this will also do the similar thing, and this is called uniform initialization. So these are the typical declarations and initialization of your vector, and accessing the element is actually like this. You can access the element using traditional way of the operator, or you can use this add function. The difference is if you have vector which is actually having, let's suppose, 3 element in this, and maybe you are asking 5th or 10th element or 1000 element, then in that case it will actually give some garbage value. But at will give you an exception saying that you are going out of bound. So this is exception safe, this is not exception safe. Okay, so this is the only difference. So this at is covered, this is covered. This is actually the older way of accessing the array. Front will give you the first element in the array. Okay, so if you'll call, let's suppose you have some ARR, then ARR dot front, and this is a function, so this will return the first element in the array. Back means it will return the last element in the array. And data, yes, this is important function, this will return the pointer of that array inside that vector class. So I explained you that, right? Somewhere here, yes. See, what I was talking was this array will be pointed by some pointer, and that data will return the pointer of this one. And I actually forgot to mention one more thing. There are two things, capacity and the size. So you should be very careful when you are actually getting the size of the array. So let me tell you that initially, let's take the example of this one only. So initially this vector was empty. Now you inserted 10, 20, 30 and 40. What is the size of the vector after this statement? The size of the array would be 4, because we have 4 live elements inside this. But the capacity can be more than this. Why I'm saying can be more than this? Because I assume it is actually a compiler dependent, and if it is not compiler dependent, then I have already explained that what should be the capacity of this. Capacity means, as I explained, when your capacity will get filled and you are inserting the new element inside this. So 40 was not able to be inserted here, right? So you created 6th size element because you already had 3 size element. Then you will go for double. So you will have capacity of 6 here, and here 12, and next time it will be 24. Yes, so it will keep on doubling if you want to insert some element and it cannot insert that. So it will actually double the size of the array, assuming that you will insert so many elements. Okay, so let's come back. So as we have already talked about all these things, insert, emplace back, pop back. Actually pop back will actually remove the last element from the array. Okay, so this is very simple. Resize will resize, swap will swap 2 vectors, erase will actually erase the elements from the vector, and clear will actually remove all the elements. So this is important. This is actually swapping, so it's okay. This is also kind of important. This is very important, and this is very important. And this is also important because insert can actually give you the way to insert in the middle of the array. So we have so many important functions to be discussed, and I have decided that I'll discuss in the next video. So thanks for watching, guys. Please comment and let me know what do you think about this video, and is there any scope of improvement or something? Please let me know. And if you like the video, don't forget to hit the like button and subscribe for more content like this. And yeah, in next videos we will see maybe this erase part. So I'll see you in the next videos. Bye-bye. Hello. This is Rupesh and you're watching CPP Nuts video series on C++, STL series. And this video is not actually a bigger topic, but it is really very important because here we'll see what is the best way to use vector in C++, or what would be the optimized way to use vector in C++. I would like to discuss what is the problem in the vector, then we will see the solution. The problem is, actually it is not a problem, it is a feature, but it turns out to be a problem. See, you should be knowing first that vector is actually linked list plus array. So your linked list plus array is a vector. So linked list means you can grow dynamically. I mean, this is the best feature linked list have, and the best feature of array is order of 1 access time. Agree, right? You access the array element using suppose ARR 0th position or maybe 100th position, then it doesn't go like linked list. In linked list you have so much of linked data, it traverses through all the linked and it reaches till the data. But in array it is not like this. In array, if there is an array and you want to come to this place, you will just say that okay, 0 1 2, I want array of 2. you will directly come here. You will not traverse from here to here to here. No. So the access time is faster in array. But the problem with the array is it cannot grow dynamically. It is fixed. Once you have said that I will be using this much of the array, I mean ARR of n size or some size, it is fixed. You cannot change the size of the array, right? So this is the problem with the array. And the problem with the linked list is you have to traverse to reach to some element. But the benefit with the linked list is it can grow n number of time. So what people thought, okay, let's create a container. People thought that let's combine best feature of the linked list and best feature of array into one thing only. Okay, and that came out as vector. So if you have something like this, vector of integer vac, then you can actually simply do like this, right? Push back. So simply I will just write in short form pb. Okay, pb1, correct? Then this one will go inside this vector, and then you can do this pushback n number of time, like 2, 3, 4, 5, and all those elements will actually get into this vector, correct? Now listen carefully. Do you know how actually it is growing dynamically? Because let me tell you one thing, this vector is a class, is a template class, and we are passing the type as integer, and this class internally have one array, okay, and that array will grow dynamically. So what is the logic or how they achieve growing this array dynamically? If you will understand that, you will come to know that, okay, what is the problem? Okay, so concentrate well for next few minutes. You will be so happy after that. So in order to understand that, I would like to run this program. This is a program, and we are going from 0 to 32, and we will push this I. See, this is I, and we are pushing this I into this vector, and I'm just simply printing vector dot size and vector dot capacity. And what are all these things? I'll tell you when I will show you the output of this. So let's run this. So a dot out. See, I have run this. Just I have simply added this size and capacity so that it will be very easy for you guys to understand this. So see, this is the output of this program. Now concentrate here very well, because it is going to change the way you should think about the vector. Okay, so in order to explain you what is this size and capacity, let me take this first example. So we are printing this first time here after inserting one element inside this, correct? So the size is giving 1 and capacity is also giving 1, no problem. So actually before this statement, when you actually just did this, the size and the capacity of this vector was 0. Size and the capacity. So assume that there are two member variables of this class. So this size is going to hold how many elements are there in the vector. So you know what, this vector size was 0 and capacity was 0 initially when we was at this line. So as soon as you push one element, size becomes, see, 1 and capacity becomes 1. I'll just simply write it. Then after that you go again back and you insert. So size will become 2 because you are going to insert 1 now. See, before initially you inserted 0, then now you are inserting 1. So how much size it is? 2, and capacity is also 2. Notice this, I am not talking about I here. This I is not this one. This is size, okay? And this is capacity. So initially size and capacity was 0 at this line, and then it became 1 and 2 and 1 and 2, okay? After 2 time execution of this one. Now again you will go back and you will try to insert 2 inside this pushback. Then size become 3, but capacity become 4. What is this? So let me tell you that size denotes how many elements are there in the vector, and capacity denotes how much element my vector can hold. So as I said, this vector will internally have actually a array. So initially it was 0 and 0. Then you inserted one element inside this, then size become 1. Then in this case, you know what would have happened? This particular case, it would have created one array and inserted what? 0 inside that, correct? Because initially we are inserting 0. So what is the size of this one? Size is 1 and capacity is, yes, 1. Now next time, at this time, you are inserting 1 inside this, so there is no place, correct? Inside this array. Now listen very carefully. When there is no place, then you have to double the size of your capacity. It will double the size. So this time it will be 2 array. So this 0 will come here and this 1 will go here. So we have inserted 0 and 1 at this line. See, we have 2 elements inside this, so size is 2 and it can actually hold 2 elements, so capacity is also 2. Now when you are going to insert third time this 2, you are going to insert into this similar array, right? But there is no place, so capacity is actually equal to the size. So as I said, you will double the size or capacity of your current capacity, so you will become 4 now. Okay, so this time it will be 4 and this 0 and 1 will come as it is. I mean, you will copy it and this 2 will come here. Then after this operation, your size will become 3 and capacity is 4. See, it can hold 0 to 3 elements, so the capacity is 4, so it can actually hold 4, but you have size equal to 3. Notice this, you have size equal to 3 but capacity is 4. Now you inserted 3, means this I became 3 and you are inserting that. Okay, so after this size will become 4 and capacity remains 4, because actually when you wanted to insert something, there was a place, so it got inserted there itself. So 0, 1, 2 and 3. So that's why 4 and 4. See, 4 and 4. Nothing changed because there was the place. Now when you are going to insert 4 here, obviously size will increase by 1, but that 4 cannot come here because array is full. So as I said, you will double the capacity what you have current. So you will become 8 now. So notice this, in 5 you have 8 now. So can you see this? You are actually doubling the size. From 1 you became 2, from 2 you become 4, and then 4 to become 8, correct? Now if you will notice here, when you are going to insert 9th element, I mean when you are going to have 9 element in your array, your capacity is getting 16, and when you are going to have 17th element, your capacity is becoming 32. So it is getting double from here to here, here to here, then from here to here, here to here, and then from here to here. Okay, so whenever your internal array of this one cannot accommodate new pushback, then what it will do? It will create another array and copy all those previous elements from older array to new array and then push back this new value. So this is how it happens. Okay, now you have understood this, how it happens. So this 0 was actually copied from there to here. This 1 was inserted because you did this pushback. Now when you wanted to push this 2, there was no place. So what you did? You created another array. So you copied 0 again. So notice this, you are copying this 0 again. And then this 1 is also getting copied. Then you inserted 2 here. Okay. Now you wanted to insert 3. That is okay. You have the place. So it's okay. You just inserted at this place only. This was empty, so you just inserted that. But then when you're going to insert 4th element, your size will become 5, but you don't have that much of capacity, correct? You have this one. So you just doubled your size and then you copied this 0, 1, 2, 3, and then you are going to insert this 4 here. Okay, after copying this. So can you see this? There are so many copy from here to here, here to here, here to here. I know you are not doing this, but actually your computer is doing this and it is taking time. So the solution for this is you should actually go for a function called reserve. So you can actually simply do like this, vector dot reserve 1000. Then what it will do? Actually internally it will create a array of 1000 size from 0 to 9, 9 and 9. And then if you will do pushback, it will push 0 here, 1 here, 2 here, 3 here without doing all these things. because you already said initially after this line that I want to reserve 1000 array. And yes, sometime actually you know how much array you want, or actually you know tentative number that much number I would like to have at least. Then actually you can give that much number, or you can start with that much number and later let it grow. So what I'm trying to tell you is, when it will hit or insert the last element here, and let's suppose we are going with this iteration only, then here lastly it will be correct 9, 9 and 9. Okay, so anyway your array is going to get double after that, but before that you actually saved these many operations, actually more operations, and it depends that how much you want to insert, and that many time it will get doubled. Okay, it can tell you with this capacity increasing, like 1 to 2, 2 to 4, 4 to 8, 8 to 16, 16 to 32, and if you will go for 33 after this, then this 32 will become 64, and then if you are inserting 65th element, then this capacity will double than this, then double than that. So you can see that it is unnecessary doing all these copy, because you cannot grow the array. Correct? It is not possible. So it will actually create a new array and copy all those older values, and this is a problem. And you know the solution now, right? You just have to say reserve this much space for me, so compiler will do this for you. There is another function dot resize, and here also you can pass 1000, but here it is little different. I think I should create another video for this. So what we have learned is, we should not simply create a vector and start push back on it maybe 1000 or 10,000 or 1 lakh time, because it will end up doing all these copy. So instead you should just do vector, you should create it and then you should resize it. Let me just give you a running example so that we can feel it is working. Okay, so this is the program, and I have just added this reserve line after this, and this full thing is actually similar, and you will feel that there is no copy anymore. So let's compile and run this, and you will notice that the capacity is 1000 initially and it didn't change. Can you see this? And your size was actually changing one after another increment. See, you was just simply incrementing these values, right? You was just pushing to this vector, so size was changing and it changed till 32, but capacity was 1000. So actually you had very big array like this, and you just did pushback of 0, 1, 2, 3, 4, 5 till 32, and remaining after that till 99 it's free only. You can do further pushback till 99, and once you will reach 99 and you are going to push another element, then the size will get double, and we'll see that example also. So let me just write or change this code a little bit, or I should just simply change the size. So I would say please reserve 31 for me, and I am incrementing till 32, right? So when it will come and increment the last time, the capacity will get double. Okay, so let's compile this and execute this. See, last time this capacity became 62 because we said please reserve 31 for me. So initially it was 31 only. See, it was 31 and size was increasing till 31. It was 31, but the moment you inserted 32 element inside that vector, the capacity increased by double, so it became 62 now. Okay, so these many steps happened, but there was no copy of this array like this. You have these many copies, right? And here there is no copy. Can you see this? So this is why I wanted to explain you guys. So leave a comment and let me know what do you feel about this video, and if you are happy with this video, hit the like button, and you want to see more videos like this, subscribe to my channel. You will get more videos like this. So I'll see you in the next video. Bye bye. Hello. This is Rupesh and you're watching CPP Nerds video series on STL series, and this topic is not a very big topic. It's just a internal topic. It's container inside container. So many people think that container inside container, what does it mean? So this is how it looks like. So one vector containing another vector. Okay, So some of you might be wondering, why am I taking this topic? So it will be very clear once you will see the problem. So let's look at the problem. The problem is you have this tree and it is looking something like this. Okay, so this is a tree. And now if I'm telling you what would be the data structure you will take to just quickly solve the problems related to the tree. I mean, you are going to some competition exams and then you have to write some programs, right? So if you are really taking linked lists and all that, then it will really take so much of time to actually build your corpus and you go for your solution. No, what you will do, you will use something like this. I mean, this is what I used to do and millions of people are doing this. So you might be thinking how I will solve this problem using this vector of vector. So let's quickly see that. See, you know that if you are using only one vector, then it would look something like this. Correct? Now you will have 0th position, 1st position, 2nd position and 3rd position. But this is vector of vector. So one element itself is another vector. So let's tilt this in this way. So it will be very easy for us then. Let me just create it like this. Each and every element of this vector is actually holding another vector. Okay, this one is holding another vector. And like this, everyone is holding their own vectors. Okay, so these all are holding the vectors. So now when you say that from 1 you can go to 2 and 3, then this is your 0th position, this is your 1st position. So you'll say that from 1 I can go to 2 and 3. That's it. And if there is some another line going from 1 to something else, you will put that here. Okay, and now see, from 2 you can go to 4 and 5, right? So this is your 2. From 2 you can go to 4 and 5. Correct? So this is how you will create your data structure, and it is really very easy when you will see this program here. So now quickly see which one is the biggest one. See, this 8 is the biggest one. So at max you can go till 8, right? So 3, 4, 5, 6, 7 and 8. So this is your 7 and this is 8. So total it is going to be 9. Correct? So see here, we have this vector of vector. We will call this a tree, and then this is edge. So this particular thing, this arrow is called edge. I have written the program in such a way that whatever edge I will give, it will resize this tree that much. I mean, this is the length of this tree. I mean, how many edges will be there? So for now, we'll say that there will be 8 edges. Okay. So 1, 2, 3, 4, 5, 6, but we'll say 8. Okay. So that we can put this 8 in the end. So we'll put 8 here, and notice this, we are using resize, not reserve. Okay, so 4 we will take input, n1 and n2. n1 is the source and n2 is the destination. So if this 1 to 3 is there, then the input would be like this: 1 to 3, 2 to 4, 2 to 5, and then 3 to 6, and then 3 to 8. Okay, so this is your source and this is your destination. So we will take these inputs and tree n1. This is very important. See, n1, so using tree, you are directly going to that particular position. So initially, let's suppose you are giving this 1 to 3. Okay, so this n1 is 1 and n2 is 3. So 1 push back 3. So this, you are pushing back 3 here. Let's suppose this, there is nothing inside this. So you're just pushing back in this array, sorry, vector. So 3 has come here. Now you will say 1 to 2. Oh, sorry, 1 to 2 is missing here. So you will say 1 to 2. So again, we'll push 2 here. Okay, like this. So after pushing all these things, I mean the edges, your vector would look something like this. So using container inside container, see, it is not limited to the vector inside vector. You can insert anything inside this vector. Vector can contain map, can contain sets, multiset, ordered set, unordered set. So many options are there. Actually, if you will mix all the containers with other containers, you will find that combination is superb. Okay, and by this video, I just wanted to show you this example with this simple example. And then this is just a range based for loop. So if I will use tree and I will apply a range based for loop, so I will iterate over this vector first and I will get first vector. So line by line we can print this. Okay, I'll show you how this will look like. So our entries would be 1 to 3, 2 to 4 and all that. So let's compile this. Okay, now it is asking me how many edges, and how many edges are there, if you remember correctly? 6. So 6 plus 1, 7. We can give 7 edges, but it's okay. We can give 6 also, right? So 6, hit enter. Yeah. So what was that first edge? 1 to 2, sorry, and then 1 to 3, then 2 to 4, 2 to 5, and then 3 to 6, and then 3 to 8. Hit enter. So see, we are getting 2, 3, 4, 5, 6, 8. And if I'll show you this, see, 2, 3, 4, 5, 6, 8. Okay, this was our vector, right? 2, 3, 4, 5, 6, 8 after this tree. So you can clearly see that 2, 3, 4, 5, 6, 8 is coming after this output. Okay, so this is very easy and it will make sense when you will do the practice with this. Okay, so don't forget, one container can be combined with another container and it will be a magic if you will use it correctly. And it will be very easy for programming competition. That's why I use all these things, so that your main focus is to solve the problem, not actually think what data structure or how you should code. Okay, your focus should not be on that. So if you have any doubt, let me know that. I'll try to fix it. And thanks for watching, guys. I hope I'll see you in the next videos. Bye bye. Hello friends, this is Rupesh and you're watching C Peanuts video series on C++, and today's topic is Emplace in C++. I'm sure so many people would have seen insert, push in STL, but Emplace is quite rare, but it is really very important. Okay, so this video is going to be whether you should use insert or Emplace, and which is good and which is not that good. And in some scenarios you cannot use Emplace. What I mean is, okay, let's start from the beginning. So the point is, all the containers support insert and Emplace operation to store data. So I'm sure you might have seen push and insert. I mean, push is not there for each and every container. Sorry, STL container, yes. But insert is there in almost every container, and Emplace is also there for every container. But the point is, they both actually store the data inside your container. What I mean is, let's suppose you have this set here, which is taking this a data type. This is a class here. Okay, so this is going to take objects of this class inside this. Okay, so we have two options. We can go for insert and Emplace. Okay, so second point is, Emplace is used to construct object in place. This is very important point and avoids unnecessary copy of the object. So what is unnecessary we'll see in a moment. Wait a minute. And the third point is, insert and Emplace is equal for primitive data type. Yes, actually if I'll give you the difference between Emplace and insert, and if I'll use primitive data type like integer, character and all that, then it won't make any sense. So that's why I have created this class for you, and this operator I have given so that this set can compare one object with another object so that it can place inside its own data structure, whatever it uses. So this is the minimum requirement actually for your class, so that you can use set for that class objects to be stored. Okay, so insert and Emplace is equal for primitive data type. They don't make any difference here when you use primitive data type. But when we deal with heavy objects, like if you know image processing, image have so much of data. Okay, so it depends how big image is, but still it will have so much of data. So if you will use insert or Emplace, it will make a big difference there. So we should use Emplace if we are looking for efficiency. So let's see what actually it means. So first, let me just comment out this Emplace here and save it, and let's compile this. So if I'll compile this, it's compiled successfully, and let's run this. So it is saying that construct and copy. First, let's see the behavior of your program first. So see, you have this temporary object, this A, or for better clarity, I would say something like this. Let's take this out. I did that intentionally. So you have this A and you have this object and you're pushing 10 inside that and you're done. And you're giving that A here. Now you are constructing not a temporary object, and then object is passed to this insert function, and this object is now inserted into this set. Correct? This is cool, right? So let's compile this piece of code and see the difference. There won't be any difference per se. Yeah, see, again it is construct and copy. So it is obvious that first you are constructing the object and then you are placing that inside your set. And then let's suppose you don't need this object anymore here. Why you created this object in the first place? Just because you wanted to insert this object inside this set so that you can do some operation. But now you don't need this. So what happened actually, you created an object. So the constructor was called here, and then you copied that object into this set. So what happened in set also, one object was created so that this copy was called. Okay, but can you see that you are doing two operations here just because you wanted to insert something inside your set? But now listen this carefully. If you don't need this, then I have an alternative for you. What you can do is, see what you was doing before. I mean, what I gave you the example before was something like this. Okay, 10 here. Okay, sorry, 10 here. So we saw something like this, and if you will see, the behavior is still same. See, I'll compile it, see, and see, it is exactly the same thing now. So is there a better approach so that you don't have to do this construct and copy? Can you just simply construct, not copy? Yes, you can do that using this one. So what you want is, you wanted to place this object which contains 10 inside this set, correct? So let's compile this code now. What it is saying is, I will Emplace means I will construct the object inside this set. Dude, just pass me the value you want to insert into that object. Don't pass me the full object like you passed in insert case. No, I don't need that. I just need the parameters for your object to be constructed. And I will construct that object by my own. Okay, so don't worry about that. So let's compile this code now. See, voila, now we have only construction. We are not doing any copy here, and still we have this object created inside set. Let me just show you that. So for that I need something like this for auto ref. So this dot x should be there, correct? So now, yeah, so if I'll compile this now and if I'll execute this, see, we get this 10. And in case of this case, let's comment out this one and execute this one and compile this one, execute again. See, we have construct, copy, and then still we have 10 inside our set. But in this case, we ended up doing this unnecessary copy, and that's what I said, right? You can avoid unnecessary copy of the objects. And yes, obviously, if it is a trivial or primitive data type, then it won't make any sense. I mean, it is okay. But when it comes to heavy objects, then it is a problem. So let's summarize this video. Let me just see if I have something left here. I don't think so. If you have comment, please let me know in the comment section. I'll surely answer that. Thanks for watching. I'll see you in the next videos, guys. And thanks for your support. Bye bye. Hello. This is Rupesh and you're watching CVP Nerds video series on C++ STL series. And this is a forward list. So this is not a very big topic, but sake of the completeness, I wanted to include this particular topic in this STL series. Okay, so forward list is nothing but a single linked list, what you know from your C. So this forward list is a single linked list. It's not more than that, but this is an STL, so you will get bunch of functions like this to actually play with your linked list. And wait a minute, this second point is, why forward list? I mean, what is the meaning of this forward list here? Why not single list? See, you might have got this point in your mind that why its name is forward list, why not single list? So I don't know the answer for that, but forward list is also correct here, because why we use a single linked list? Because it is holding a single pointer, right? So if this is kind of a list and we have 1, 2, and 3, something like this, we used to call this a single linked list, but this is forward list. Forward means you have the option to go from here to here and here to here, but this way it is not possible. Okay, so that's why it is called forward list. And when you want to have this feature, coming back, then you need a double linked list root, and this is your second, double linked list. So you can see that you have the option to come back from here. Okay, so this thing is called list in std template. So this is called forward list, this is called list. So list means you can go back and forth. Okay, so we should use this class instead of traditional single linked list because it is well tested. Obviously, if you are writing your own linked list and you have some insert function, some remove function, and some function what you want, then you have to test all those functions and you need to be very sure that they are not messing with your data. But if you're using forward list, then this is already well written. It is an STL library, so you don't have to worry about your correctness. Correct? So this is a good reason. Second reason is bunch of available function. I'll give a good point to this also because you can see so many functions are available and you don't have to write your own functions. I don't think you may need more than this. So let's quickly go through all these functions. I have not listed all the functions, but I have picked few important ones. So insert after means if you will have list one dot begin, means you're saying that from here onwards you insert some number actually. So this is going to be, let's suppose we don't have 8 here, so let's put 8 here. So what it is saying that I want to push 8 inside list 1, but after this first element. So after this 5 we will have 8, then 4, 6 and 2. So let's verify that. And now let's execute this one. So see, we can see that 5 and then 8 is there, then 4, 6 and 2. So 5 we have inserted 8 in between, and then 4, 6, 2 are as it is. So this is how you can insert actually using insert after, and there are other variations of this function. So if you're interested, please go ahead and see those variations. So Emplace after is like, wait a minute, if you don't know what is the meaning of Emplace here, I have a video for this. Maybe just before this video I have given that video, so please go ahead and watch that one and then come and watch this one. So Emplace means it will create the object or the memory inside this list and then assign that data. So after Emplace we have reverse. So reverse is very simple, that if you will do something like this, let's just comment this and we have reverse, and this list should be reversed. So it is very easy. See, 2 6 4 5, it is 5 4 6 2, so this has reversed. As I said, it will have almost all the functions what you expect. And we have sort here, we have merge here. Merge is like it will merge two different lists. Let's do this and we will be good to go. So we need to sort this first, and yeah, merge will do its job once your list is sorted. Okay, so it is not going to merge to unsorted list. So for that, both the lists should be sorted. So that's why I'm first sorting both and then I'll merge. So let's merge list 2. Execute it and see, we have 1 2 4 5 6 6 7 9. So we have 6 2 times here. Can you see that 6 here and 6 here? Yes. And as I said, if you will not sort them, let's do that. I don't know it will do, but let's do some stuff, right? Okay, can you see that this is not merge? I mean, it is just 5 4 6 2 and 7 6 1 9. So it didn't merge. I mean, it merged, but it actually concatenated one list after another list. Just be aware what you're doing. And then we have this splice after. Oh wow, this splice. This is really very important. This is very cool function in single linked list or whatever you call it, forward list. Yeah. What it does is, let's suppose we have two lists, list 1 and list 2. What if you want to take some data of this and remove from here and place inside this one? Yes, we can do that. So that's called splice. Okay, remember this. What I'm saying is you want to remove some data from here and want to place that data here. So let's see how we'll do that. I'll just remove all these code here and splice after, and then you have to give the place where you want to start with. I mean, from this begin, you want to insert this list 2. So what I'm saying is, see, dude, please insert this list, not insert, move list 2 data, this full thing into this list 1, but I'm giving you the position. Do it after this position. So this position is nothing but this first position. So what we'll do is we'll insert this list 2 after this. Okay, so let's compile this and let's execute this. Okay, see, 57619 and then 462. See, from here to here we have this list 2 here, and wait a minute, I didn't show the list 2 data, right? So we can do this std distance. We can use this function to actually get the size of begin comma list 2 dot. Okay, so this will give you the distance from begin to end for this particular list. So we can just simply compile again and execute this. So and the distance is 0. Okay, let's make it clear. See, size of list 2 is 0. So we don't have anything inside this. Okay, so then this unique means it will remove duplicate values, and this remove means it will search for that element and remove. This is very important. Let's do this. List 1 dot unique. Quickly print this. It should have only unique values. See, 5462. It doesn't have two times. Okay, so it will remove all those duplicates. But wait a minute. This unique is very tricky. If you will have this 2 somewhere else, let's suppose here, then it will not work. I'm telling you. See, if we have 2 here and here, but still it is duplicate, right? And if I will compile this, let me just simply compile this, compiled and execute, and we will see that, see, 52462 is there, but this unique is little bit tricky. It will not remove everything. It will just remove the adjacent duplicates. Okay, so be aware of that. Okay, unique is done. I don't know, maybe there is some another version of this unique. So if you do know that we can remove this 2 from here using this unique, even though it is not adjacent duplicate, please let me know in the comment section. I don't want to go and check that. It's not that important, but please do go and check if you are watching this video and want to know that. And this remove will actually remove all the matching element. What I mean to say is, if you will use this remove and you will say 2 from here, let's do that, because we already have two time here. See, 546, 2 is totally gone. No matter how many times you have 2, it will remove that. Okay, so this works fine, but this unique is a little bit tricky here. I don't know, I don't remember why it didn't click my mind. It's okay, it's okay. And this remove if, wow, we have this with us. What if you want to remove all the entries greater than or less than some number? So there you go with this remove if, and then you have to pass not this, some lambda function. Okay, lambda function here is little different than Angular. Right now I'm in Angular mode. I'm working in some Angular project. So yeah, this is the lambda function for C++. Thank God. Okay, so what we want is, we just want to return true. Maybe this number is greater than what number? 4. Let's do that. 4. So if this is true, integer n. Okay, so this will remove all the numbers from this list greater than 4, means it will remove 5 and 6. It will keep 2, 4, 2. Let's quickly check that and summarize this video. See, 2, 4, 2. And so this is working. And then resize. This is also a cool function. I don't know why I like all these things. I don't know. Maybe I'm happy because I'm getting these things freely available. Okay, so we have this list one dot resize. You have this resize function. Resize will actually resize your stuff. Means if you will give 2 here, means it will delete the rest of these 3. Okay, you want to check that? I should have not removed that code. Yep, let me remove this, and then list one dot resize 2, correct? And let's quickly compile, execute 5 and 2. See, 5 and 2, 4, 6, 2 is actually gone. Now what if you want to give more than that? So we have 5 elements. What if you are giving 6th element? 6th element will increase 1 element and it will keep that as 0. See, we have 0 in the end. 5, 2, 4, 6, 2 and this 0. Okay, so resize actually does a pretty good job here. And there are so many functions like this. If you want to see, go ahead and Google or check the standard website. So I hope you enjoyed the video. Don't forget to hit the like button if you liked and subscribe to my channel so that you can get the notification for upcoming videos like this. I'll see you in the next videos, guys. Bye bye. Take care. Hello guys, this is Rupesh and you're watching CVP Nerds video series on C++ STL series, and this topic is about list. So yesterday we saw a forward list, which is nothing but a single linked list, and today's topic is list, and this is a double linked list. So don't ask me why it is list. I don't have any answer for that, okay? But list is actually a doubly linked list, what we know from C programming language, if this was your first programming language. So list is a sequence container. I don't know, did I talk about this sequence container and this ordered container and unordered container? So this particular topic lies into a sequence container. So there are 3 types of containers. First is sequence, second is ordered container, and another one is unordered container. And it allows non-contiguous memory allocation. So let's just quickly draw this doubly linked list. So your doubly linked list looks something like this. We have this header here, and as it is doubly linked list, we have 2 pointers. This is a pointer location and this is also a pointer location, and this is your data location. So we all know that in doubly linked list your node look like this. Okay, so we will have data here, let's suppose 1 2 3 4 or some object, and this place is for your left hand side node and this is for right hand side node, and that's what you can see here. Okay, so for this particular node we have this one as right, so from here to here, and then the left node is this one, so from here to here. So each and every node inside this will have something like this. Okay, so list is faster compared to other sequence containers, and it is faster in terms of insertion, removal or moving elements here and there. But the important point is our position iterator should be there with us. So what I mean is, let's suppose you have so many nodes like this. Okay, 1 2 3 4 5 6 and 7. Okay, so reverse is also there. I'm just quickly drawing this. Okay, now what you want is you want to insert something in between 2 and 3. Okay, here then doubly linked list is faster provided we have the iterator. I mean, let's suppose you have this list here, list 1, and what I'm saying is we want to insert something here, right? So let's insert something in between these two, I mean 2 and 4. Then in that case you should have the iterator for that particular position. Then you can directly insert that in between. I mean, what you just have to do is just create this. Maybe you want to insert 8 or something. Then what you will do, the next would no longer be this. I mean, the previous of this one would be this one, and the next of this one would be this one, and the previous of this one would be this one, and next of this would be this one. Okay, and this connection is gone. Just think, if you are supposed to do the same thing in vector or array, I mean array doesn't provide that, but in vector, let's suppose you have this 1 2 3 5 6 and you want to insert 4 here. I mean 4 is missing, right? So you want to make it look like this, something like this. 4 should come here. For this, what you have to do for vector is you have to internally create another vector. I mean, I said initially your vector is like this, you have to create it like this. Internally, what it will do, it will create an empty array inside vector. It will copy 1, 2, 3 from here, from here to here, and then it will place 4 here, and then 5 and 6 will be copied. So can you see that there are so many operations involved? And yeah, lastly, it have to delete these, okay, after copying everything to the new vector. But can you see in this case, we just added one node without any trouble. We just changed the pointer, 3-4 operations, hardly. And if you're thinking it is not very big difference, let me tell you that if this vector is very big vector, maybe the size of the vector is maybe 1,000 or even more than that, or lakh or something, or million, then it is a really very big problem to actually create that much big array and then copy everything. So that's why it is called very faster in terms of insertion, removal, and moving stuff here and there. Okay, now let's move to the next point. We should use this class instead of traditional doubly linked list because it is well tested, correct? Because if you are using this list which is coming from STL, then you know that okay, somebody have created this class and they have tested thoroughly for you. So there is no leakage or there is no problem in this doubly linked list. So instead of creating your own doubly linked list class and working on that, I would prefer using this as a base class, and then you just do whatever you want, wrap it or do something, but do something on this. So this is a very good thing for starting. And second point is bunch of available functions. Yes, this is really very important because mostly you will be using all these functions, and I have not listed every function here. I just created this list so that you can get the idea about this doubly linked list. Okay, so the first thing is operator is equal to means you want to copy this list 1 into list 2, something like this. And if you do this, you can just simply say list 1 is equal to list 2 semicolon. That's it. Then list 2 content will go into list 1. And let me tell you one thing. If this is the case, like we have list 1 data, list 2 data, and you assign list 2 into list 1 using this equal operator, then list 1 data will go from this list. It is like you are copying this data into this and discarding this already available data here. And this is what the traditional behavior of this equal to is. If x is equal to 10 and if you will initialize s is equal to y, where y is of some 20, then this 10 is gone, right? So this is what will happen here also. Assign is very simple. You will assign number of elements inside this list, front and back. This is very important. We did not have this back in case of this forward list, singly linked list, but we have this back function. Front and back means if suppose this is your list, then front will give you this and back will give you the last one. This is what the use is. Empty, it will check whether this list or whatever it is empty or not. So it will return true in case of empty. Size, we did not have this particular function in forward list, but we do have it in doubly linked list, and it will give you the size of the list. Max size, obviously it will give you the number, how many elements you can have inside this your doubly linked list. Clear means it will clear your list. Now let's start from here, like insert, Emplace, pushback. Insert is, as the name says, it will insert the data for you. Emplace, I have given a video for this. I won't be discussing about this much. Emplace means there is some optimization involved. So please go ahead and watch my video on Emplace. Pushback, this was not there in forward list. Pushback, pop back, push front, and pop front. Pushback means it will insert that element in the end. And pop back means it will delete that element from that end. And same, push front means it will insert element in the beginning. And similarly, pop front means it will delete the first element from the list. And similarly, reverse will just simply reverse it. Sort will actually sort your data. So let's do the practicals and we'll understand a little better. So now just see the output of this one. So I'll just simply compile this, execute this. So see, we have list 1 data and list 2 data. So this is fine, right? So let's do some operation. I wanted to sort these, right? So let's do this. Let's go ahead and compile this, execute this, and it should be sorted. See, 2, 2, 4, 5, 6, 1, 6, 7, 9, and this is a sorted order. So merge will actually merge 2 linked lists. So let's quickly do that also. I want to merge list 1, merge list 2. Then we will have list 1 and list 2 merged inside list 1. Let me comment out this one, otherwise it will be unnecessary of outputs. Execute this. See, the data is 1, 2, 2, 4, 5, 6, 6, 7, 9. So this have actually merged these two doubly linked lists. So this is quite easy, right? I mean, we don't have anything to learn here. I just wanted to show you how quickly you can get doubly linked list feature in your program without actually writing it. So we have these many functions, and yeah, splice, unique splice does nothing, just move one list's content into another list. So let me just show you that. And if I'll compile this, execute this, see, we will have these two lists 76195242. So you said that splice list 2 from beginning itself. So what it will do, it will append this full content in the beginning of this one. Okay, so that's what we see here, right? Because when I talked about this operator equal to, I said if you will initialize this one into this one, then this full content will go off, right? So let's just quickly see that also. If you will do this list 1 equal to list 2, it means you will delete list 1's content and copy list 2 here. So we can quickly view that. See, we have list 1 equal to list 2 only. See, 7619 and list 2 is also 7619, and we are printing list 1. Don't mistake here. So there has to be some way to actually merge these two, right? So this splice is actually for that purpose only. And wait a minute guys, there are so many versions of all these, almost all the functions like splice and remove, insert, Emplace. They all have different versions of these functions. Sometimes someone will take 2 arguments, 3 arguments, I don't know. So depending on your situation, you can actually choose what overloaded function you want for your use case. So unique will actually remove duplicates from your doubly linked list. Let's quickly see that. So we have this 2 comma, let's suppose again 2 here, and we can see this list 1 dot unique, and let's compile and print this. I'll compile this and print this. See, the point is, as this is a linked list, it will make linked list unique in terms of adjacent nodes. What I mean is, if this is 2 and another 2 will come just after that, then only it will be considered as duplicate. Otherwise, see, we have 2 here and 2 and 2 here, but it just removed either of these 2, okay, from here. But this 2 is still there, correct? So if you will add another 2 here, it will still remove these 2 or these 2 or I don't know, this one or this one, just implementation, but it will remove adjacent duplicates. So don't be mistaken here. It will not make your list unique if elements are scattered here and there. So there has to be adjacent so that you can actually remove them. And wait a minute, I'll tell you a quick trick. You just do one thing, list sort them. If I will sort it, obviously this 2 will come together and then it will remove. So let's quickly compile this, execute this. Now see, 2, 4, 5, 6. We have no duplicate here. So did you like this video? If you did, don't forget to hit the like button guys, and make sure you subscribe to my channel so that you can get the notification for upcoming videos like this. I'll see you in the next videos guys. Bye bye. And if you have any suggestion for me, please drop a comment. And if you want some specific video, you can give comment for that. I'll try my best to bring that if that suits the current requirement. Thanks again. Bye bye.
Hello friends, this is Rupesh and you're watching CPP Nerds video series on C++, and this topic is map in C++. So this video is a part of an STL series. So let's understand this topic. The syntax is like this. We have map T1 and T2. These two are type and this is going to be your object name. So this is the typical syntax for your map, where T1 is key and T2 is a value type. We'll see all these things here, but let me just go through these points quickly so that we will be able to understand all these things a little better. And the second point is, this is an associative container that store element in key value combination. So this is first time I'm talking about the key value combination in STL series. So assume some data structure or some tree for that sake, and think that if you have some object and you want to store that object in such a way that retrieval should be faster. So you have this key and value pair, and key can be anything, like it can be a name, it can be a number. So here, as I can show you the example, that I have taken key as name and this value is as number. So this example is of a dictionary example. So on this key you are storing this value. Okay, so if we will go through another point, and yeah, I just forgot to mention one thing, that this key is unique. If you are keeping this Amit as a key and assigning this value, then you cannot have another key with the same name. It should be different, and values can be similar. So if you have key 1 and here you are keeping 2, then you cannot keep 1 and some another value, something like 3. No, this is not allowed. Okay, but what is possible is, let's suppose you have 5 here and this is the key, then you can again have 2. So values can be similar across keys, but keys should be unique. Okay, whatever key you are using, and depending on the keys only, your tree will be formed. And next point is, it is implemented using self-balancing binary search tree like ABL and a red black tree. So if you remember, your BST was something like this, right? Correct? So this is your root, and all the left hand side of this root are lesser than this root, and all the right hand side are greater than this root. Okay, and this property applies to each and every element in this. So if you'll see this, 3 is less than, but 4 is less than 5 but greater than 3. That's why it has come to right hand side, and 2 is less than 5 and less than 3, so it has come here. So this is the proper binary search tree representation. And if we are saying that internally map is using red black tree or AVL tree, which is a binary search tree, they have just little bit tweaked it and they called red black tree and AVL tree. The basic funda is this, it is like this, so that if you want, or you are saying that I want 7 number, so we will start from here and then we will be knowing that, okay, 7, so 5, so we have to go right hand side. Correct, because 7 we are looking and 7 is greater than 5, so we'll go inside or towards right hand side and we will get that 7. Or if you are looking for 6, then obviously 6 is greater than 5 and we are reaching here, and then we'll see that, okay, 7, so 6 is less than 7, so we'll go left hand side, so we'll get this 6. So in order to achieve this behavior, whatever data you are inserting should be comparable. Then only we can take the decision where should we keep them in this tree. Okay, so if it is number, then it is very simple for map to take the decision and come to know that, okay, this is greater than, this is less than. And in my case, we are using string. So as this is string, this string class have all the comparison functions. I mean, you can compare one string with another string and it can tell you that which one is greater and which one is smaller. So then there is no problem. But problem comes when there is a user defined data type like person. I took this similar example yesterday. So in case of person class, you have age as a data member and another one is name. So this is going to be your string data type and this is going to be your numeric data type, or you can take a float or double. Okay, but as this is an object, and when you will try to insert this object as a key, then it is a problem, because this map doesn't know how to compare two different objects. obj1 is equal to obj2. I don't know how to compare this. This is what it is saying. So we have to give compare function for user defined data types, but we don't have to give any compare function for integral types or inbuilt types. And this string have already the compare function, so there is no problem here. So I'll take the example of user defined data type and we'll be very clear. So I think I have covered all the points here. It is using self-balancing tree. It is store key value pair in sorted order. Yes, I just could not see this. Yeah, see, I have written it. It stored them in sorted order. This is also very important. See, this is a sorted, right? So if you'll apply in order traversal like If you forgot that, I don't know, I should talk all these things here or not, but if you will apply in order traversal, this will come out as 2, 3, 4, 5, 6, 7, 8. Okay, so this is actually in sorted order. Now you might be thinking, in what order, ascending or descending? That we can decide after giving this type 1 and type 2. We'll apply comma and we'll give, we want greater than comparison operator or lesser than comparison operator. So last point is, STD map is generally used in dictionary type of problem. What is dictionary type of problem? Dictionary is mainly like you have one key and it can have multiple values, or at least one value should be there. Okay, that is kind of a dictionary problem. So if you remember a dictionary and you are searching for some word like hello, then there will be only one hello in entire dictionary. Okay, so the similar case applies here. If you are making something as key, then that key would be unique key in entire map. Okay, so having said that, let's jump into this and see how it works. So before that, wait a minute. How you will create a map? I already said you will be giving two data types. One will be the key data type. First one is for key data type. So I'm keeping key as string. So I'm giving a string here, and the value data type is integer. So I'm giving integer. There are different ways to do this. And one of the way is you just have a map object and you use this syntax to actually insert the value, which is this one, at this key location. Okay, and similarly you can do this as many times you want. Okay, and there is another way of doing this, map.insert std make pair. So this will also do the similar job but in some different way. And let's suppose you have updated three values, 1, 2 and 3 here, and let's suppose you want to iterate over this map. So this is the way of doing that. You can iterate using loop, and this is range based loop, and we can just have this element 1 and dot first would be key and dot second would be element. So if we are looping through this full map here, then first value or the first element which is coming out would be Amit if we have used ascending order sorting. Otherwise, Chotu will come first, then Bot, then Amit. Okay, it will be in reverse order. So we'll see that, and obviously if you want to access some value, then you can just simply give map and that key and it will give you that. And this one returns the reference of that value so that you can change it. So what I'm saying is, if you have this map Chotu equal to, let's suppose you're saying 0, then it will change this key's value. Before it was something and now it will become 0. Okay, so you can actually update it. But the important point to notice is you cannot change key. Once this key has gone into the system, it will remain like this forever. You can only change the value part. Okay, don't miss this information, it is really important. So let's look at the compiler and run this code. So if I'll execute this, see, we are getting Amit, Bot and Chotu. See, Amit starts from A, so it is smaller than B, then C. Okay, so this is in ascending order, and after this I am getting this just because lastly I am printing this. So let me just comment this one, and then it will be easier for us to see this. Let's compile this again and run this. See, now it is Amit, Bot and Chotu. So this is the default behavior. This is ascending order. What if you want to store that in descending order? So you have to use greater for the comparison. Okay, before it was less. So if you will use greater here, and then you have to give this to brackets, here you have to say that on what basis you will decide. Oh, sorry, what is the type you will decide on. So we have integer here, string here, then it will use the string, and it is optional, you can omit this. So let me just have this here and we'll compile it, we'll check that, and this is Chotu, Bot and Amit. So now it is reversed. Okay, and as I said, we don't have to give this string, I mean the comparison type, you just have to give this greater here, and let's compile this again and see the result. See, it is same. Okay, and let me just quickly write this less also. So if we have less here, then this is the ascending order. Let me compile this and run this again. So see, Amit, Bot and Chotu. Okay. So we have seen everything, but wait a minute. I told you that this is a dictionary and key will be one and there can be multiple of values, and multiple values we can store in vector for our demonstration. So now the pattern will change. Now this initialization will not work. We will be using pushback for this, some number. Okay. And here this will change. We need another loop to iterate over this second part, because our second in this case would be a vector. So let's have another loop here and bring that here. We can say that cout element 2 dot, sorry, no dot, it is simple thing. We just need this. So now when I will compile this, I'm sure it should work. Let me just recompile this and execute this. Whoa, there is some issue in here. Oh, let me remove this and compile this again and execute this. Correct. Sorry for this, I just forgot to remove this because this insert part will not work here because we have this as a vector. Okay, so this will not work. But wait a minute, this is not looking good, right? Let me just give one cout ENDL. Let's compile this and rerun this. See, this time it is Amit this one and Chotu this one, but this is not looking like a magic. Let me do the magic here. We will take this one and change this value by one number. Okay, and save this and then recompile this, execute this. See, this time we are getting two values for Amit because we have done pushback 2 times for this particular key. So this particular key is having 2 number. So as I said, value is type of a vector and you can push any number of elements inside this and you should be fine. So this is what I wanted to show you people. I know this is fun, and let me tell you this, if you have dictionary type of problem and your key is a non-integral number, like it is not 1, 2, 5, 8 or something, it is some name, then you cannot have vector or array which is fastest. So the second fastest is this map. Okay, you can have key and the respective values, and this is fastest because internally we are using binary search tree to implement this. So remember this, if you have key other than integral number, then you should go for map if your problem is suited for dictionary type of problems. So this is the time to say goodbye, but I'll ask if you like the video, don't forget to hit the like button guys, and subscribe to my channel so that you can get the notification for upcoming videos like this. I'll see you in the next videos. Bye bye. Hello friends, this is Rupesh and you're watching CVP Notes video series on C++, and today's topic is multi-map in C++, and it's been long time I did not give any video because I was so much busy. Okay, so now I got some time, so let's start this. So the syntax is, okay, this multi-map, so this is not a slash, this is a multi-map, and then this is type 1 and type 2 and the object name. So multi-map is actually similar to the map. If you don't know what is map, please go ahead and watch my video on map. So in map, you remember you have one key and then you have associated value with that. Okay, so you have some value like this and you have another key and you have another value for that, correct? So in map we had only one key, so if there is only one key, you can have only one value associated with that key, and key should be unique in map, whereas in multi-map you can have multiple similar key. So in multi-map it would look like this. Suppose you have 1 and you assign something in that, and then you have the same key 1, you can assign maybe something else to that. Maybe you can say 1. So if you will see in the system, there will be 2 different keys and 2 different values associated with that. Okay, so that's what I have given the example here. If you see here, we have this multi-map and the first is a type of your key. So first position is for the key and another position is for your value type. Okay, so this T1 is nothing but the key type and this T2 is a value type. So with this example, you can see that I have key A and A 3 times, and I'm initializing 1, 2 and 3 as value in that. So if I will iterate over this multi-map, which is like this, there are other ways to actually iterate, but I will choose this way so that it will be very simpler. And yeah, obviously it store sorted list. Okay, sorted list. So let me just first read these comments so it will be very handy for us to go ahead and discuss all these things. Multi-map is an associative container that contains a sorted list of key value pair. Correct? So we have key here and the value. Okay, so we have key and value, and key and value type can be anything. So while permitting multiple entries with the same key, this is something unique with multi-map. That's why it is called multi-map. In map, you had only single key, but here you can have similar key so many times. Even similar key and similar value is also possible. It's not like you have to have a different combination. No, you can have similar combinations and number of time, no problem. So this is covered. Second point is it store key value pair in sorted order on the basis of key, correct, either ascending or descending order. This is important. You can actually specify that I want to store these key or these pair in ascending or descending order in map. So that is the syntax for this. See, if you will use this syntax when you are going to create a multi-map, you have this key type and then data type, value type, and this is a third place where you will say that I want greater or less. So if it is greater means it is descending order, and if it is less means it is ascending order, and if you're not giving anything, by default it is ascending order. And third point is data structure used in multi-map is not defined by standard. Yes, if you will search, you will not get anywhere written that yes, I am a C++ STL developer and I know what I have used to develop this. No one is talking about what is actually used to implement this multi-map. But red black tree is assumed by most of the people by looking at the behavior of this data structure. So this was third point. And the fourth point is lookup. So actually when you have your map ready, okay, you inserted these many stuff and now your map is ready. So now in order to iterate over that or count how many keys are there or find some key or do some operation on that, you have these many functions available. So first is count. So count is, it will tell you that how many keys are available with the given count. We'll see all these lookup functions when I will do the practical. So last point is we don't have at and this functions to get element like we had in std map. This is very important. Don't get confused that in map we had something like this, right? Let's suppose you have std map of some type and you have this obj, then using this obj, and if suppose your key type is integer, then you can do this 1 and this will return the reference of the value if it is there, okay? But this operator is not there in multi-map. And similarly, at is also not there because there is no single key available inside multi-map. There are so many, so it doesn't know which one to return. But there are ways to actually get all the keys like equal range. So if you're finding how many A's are there, it will give you that. So we'll see all these things a little later. So enough talk, let's go to the compiler and see how it looks like. So this is your actual program here. If you notice that this is just the iterating over this full multi-map. Okay, so this will give you the similar list what we have inserted here. And another for loop is to get all the key with A. Okay, so you will get these 3 entries. Okay, so let's quickly just compile this first and then we will see all those other options. So where am I? Say that 9, and if I'll compile this, execute this, see, so this is what we are getting here. So till this much is the result of first for loop because we are iterating over it, and this much is for second loop because we are saying that get all the pairs of given key. Okay, so we can see that if you are confused, let me just simply give one cout ENTL here. We will save it and recompile it. and re-execute it. See, we have one space here. So first loop is for this one and second loop is for this one. So we don't have any confusion now. So let me just go through what it is doing. And yeah, I told you that you have the option. You can actually say pair of character comma integer. So you have these options also. So let me just simply save this, compile this and execute this. I guess we are getting the output correct. So this is also a way of doing this. Let me just revert this. Okay, so till now you saw that how to insert it, how to iterate over it, and how to get some key from your multi-map. Okay, it is very easy, right? Now you might be thinking what this hack is, correct? I know this is looking like a very big hack because the return type of this equal range is little bit scary. I'm telling you, it is really very scary because it returns a pair of two iterators. How to go about it? Okay, I'm using auto here, so I'm saving my life, but I would like to show you that. Wait a minute. Pair of multi-map and the type is character integer, comma, multi-map, same thing, character integer. Okay, so this is what we get when we use this equal range function. I know you must be thinking, what is this hack? No, but this is not a hack. Actually, what happens, this equal range returns a pair of two iterators. This first iterator says that, okay, I am pointing to the first pair of a returned pair. So if you're looking for this A here, so you're supposed to get these three, right? I mean, these three, correct? So this first data type means it is saying that I will be holding the first one's address, and this second one is saying that I will be holding the last one's address. So you can iterate from first to last using this loop, and this is how you will do it. Okay, so let me just simply compile this and we'll be good to go. Compiled, yeah, successfully, and see, we have this correct output here. Okay, so we are good. So can you see the power of auto here? I can see that. It is like a god to me. Just auto, and I am living my life on beach or something. So this was about equal range function. We have count function. So let me comment these. If I'll comment this and just focus on, would you please give me that count, please? And it will give you that. And if you will just simply compile this and execute this, you are getting this little 3 here, right? So you know it is 3. So we have a 3 trine. So this is the job of count. Find means it will tell you that whether it exists or not. Oh, I'm so sorry. I'm so sorry. Find means actually it will give you any of these. I'm just confused with this contains. Okay, so if you are using contains here, let me just clarify that. Then this will give you true and false. It is like, does it contain this or not? Oh yeah, I just checked it. It is saying that this contain function is available in C++20. So I don't have that compiler so that I can show you that, but believe me, this function exists and it returns true and false depending on that key does exist or not. Okay, so let's go to find now, because this find did not work, right? And find actually returns something else. It actually return the pair. Okay, whatever it is. I know you're saying that there are 3 values, I mean 3A, so which one it will return? So believe me, it can return any one of them. Let's just simply do auto and data here, or we can say pair. Okay, and if I will just simply do this cout pair. Okay, and if I'll compile this now, let me compile this, compile successfully, and if I'll execute this, voila, see, it is giving you A and 1. So this is giving the first one, but standard does not guarantee which one it will return. Okay, so this is what find does. So we have covered count, find, contains, we could not show, and this was the first example. Lower bound and upper bound. Lower bound and range dot, not dot, second. Okay, so if I will save this and compile this, okay, let me comment this one because it is disturbing us. Recompile, execute. See, we are getting A1. So what is the meaning of lower bound? Lower bound means, see, you are giving A, then lower bound of all these are this one. Okay, because it was inserted first, so this is first in the row of sorted values inside this map. Okay, and I told you this multi-map would be sorted on the basis of key. So this came first and this came second, so this is anyway similar to this one, but it is going to be at second place. So what we are asking is, I want a lower bound of this A, so it is always going to give this one. Now there is a point here. If you will say upper bound, then it is not going to give you this one. This is the problem. I don't know why they have done this, but this is how it is. I will compile this again and execute this. See, this time it is B4. So upper bound of A is this one, not this one. This is very important to know, otherwise you will be confused a lot. So if I will give B here, so B's upper bound would be obviously this one only. Sorry, it will be kind of a 0 or something because we don't have any upper bound here. B's lower bound is going to be B4. Okay, so if I'll just simply compile this one and execute this, see, we are not getting anything. And similarly, B's lower bound is going to be, that's what I said, B4. So let's quickly compile this and check that. See, it is B4. So these are the lookup functions you can actually perform on your multi-map, and you might be thinking, what the heck is this? I mean, why I'm going to use multi-map anyways? What is the ultimate purpose of using multi-map when I'm going to have these scenarios? Yes, you can have these scenarios, and when you have such scenarios that, like, with one key you want to associate multiple values, then you would need this multi-map. There are so many people, they are thinking that why we cannot use map only like this. If I want to store these integer, which is going to be so many values for a similar key, why I can't go to map only with this data type, like map, and I have this character and the vector of integer. Why I can't go for this? Correct? So key will be always 1, and whatever values I want, I can push inside this. So even myself thought this should be a very good idea. Instead of going for multi-map, I can go for this one. But I searched, I googled it, and I found that there are so many people who thought the same thing, and they googled it, and I found that no, this is not good way to actually achieve this. So if something is already given by your standard library, you should use that, because if you use something like this instead of using this, if you're using this, then you have the pain of maintaining this. You have to see the correctness of this one. Instead of writing tests to actually find whether these things are correct, you can actually simply rely on your multi-map, which is provided by a standard library, and you can live your life happy ever after. So nice talking to you guys. I hope you enjoyed the video, and if you did, like and subscribe if you are new to this channel. I'll see you in the next videos. Bye bye.
Hello friends, this is Rupesh and I'm watching CPP Nets video series on C++, and this topic is Unordered MultiMap in C++ STL series. So this is probably the last video on this STL series. I don't know, maybe I'll create some discussion video maybe, but topic wise maybe this is the last one. So go ahead and watch the full series of this STL series, and the link is given in the description field, because I have given each and every container's detailed video. So let's start this one. Unordered multimap is an unordered associative container that supports equivalent key. Meaning, actually, in order to understand this unordered multimap, first you should be knowing what is the meaning of map. So map is nothing but a key value pair. You know that, right? Now the point in map key was unique. So key was always unique and you can assign different values to that. Now the point is, in unordered multimap, you can have duplicate key value pair, meaning you can have duplicate keys. So that's the whole point here. And the searching, insertion, removal have average constant time complexity because it internally uses buckets and hashing to actually arrange the data. So if you have created a hash one time and place your data into some place, in some bucket, then it is just that retrieving from that bucket itself. So it's a constant time complexity algorithm. So let's read out everything. Internally, the elements are organized into buckets and it uses hashing to insert element into bucket. Correct. So I have explained how this bucket thing works in my previous videos. So if you are following them, then you don't have to actually worry about all these things. So I encourage you to please go ahead and watch my full series so that you will have a link how these things actually work, because I'm not going to explain these things again and again because these things are common in between so many containers. And why we will use unordered multimap? The reason is it maintains collection of duplicates key value pair. So if you are interested in some kind of a data structure where you will need a key value duplications, then you will go for this unordered multimap. And why unordered means? Obviously, if you are again following my previous videos, then unordered means it is not going to be a sorted way. It is unsorted way. So if you will iterate over this unordered multimap, then key value pair will not be in any order. It can come in any order. So that's the whole point here. Now let's look at this program. So the program says that we have this unordered multimap, and as it is map, we will have two data types. This is a key data type and this is value data type. So I have this key as 5 and the value is D here. So this is a initialization part. Now you can insert in these many different ways. So it's like it will convert that into a pair, and you are explicitly telling that convert this into pair, and you are using this function make pair to actually make a pair. So if you notice here, we have these two data duplicate, correct? So if it was map, then it will still be 1, but as it is not a map, it is multimap, it is going to store 3C 2 times. So let's compile this and verify it. So compiled it and let's execute this. See, we have 3C and 3C 2 times. Don't tell me that I cannot modify this, so I can make actually this C and D. So let's compile and execute this. See, now it is D and C, but the point is key is duplicate here. So if you need something like this, go for it. It is literally faster because it uses hashing and bucket. And if you're not sure what is hashing and bucket, go ahead and watch my previous videos. So it's time to sum this video. Thanks for watching, guys, and like and subscribe if you're new to this channel so that you can get the notification for upcoming videos like this. Bye bye, I'll see you in the next videos. Hello friends, this is Rupesh and I'm watching CPP Nuts video series on STL series, and this is Unordered Map in C++. So before this we have seen set, multiset, unordered set and all that, and we have seen map also. So you'd like to know the difference between map and unordered map, correct? So the major difference is it is built using red black tree, and this is built using hashing, and data are stored in buckets. So this is the internals of map and unordered map. And another difference is this is used to contain the key value pair in sorted order. Key and value in sorted order. It will be sorted on the basis of key. So if you inserted something inside this map and you are iterating over the map, in that case you will get the data which is sorted based on key. Okay, but that thing is not there in unordered map because it says that I am unordered map. So if you are saying only map, means it is ordered, and here it is unordered. So these are the basic and major differences between these two. So let's go for the points here. So the STL unordered map is an associative container that contains key value with unique keys. Obviously, key should be unique. And prerequisite to understand unordered map is map. So first go ahead and watch my map video if you don't know what is map at all. And this red black tree I will explain in my data structure algorithm series. And this is a balanced binary search tree. So we'll see all these things in later videos. This is very simple video. And if you are actually following my STL series, then you will be seeing that, okay, I have this line, this line, this line, and this line actually repeated, because before this video I have explained unordered multiset, and these things actually follow in that case also. So let's quickly go through this and then we'll go for this practical and complete this video. So watch this video till end. So search, insertion, and removal have average case constant time complexity. Because it uses hashing, it has the constant time complexity to insert and remove. Okay, and internally the elements are organized into the buckets, and it uses hashing to insert element into the buckets, and this allows fast access to individual element, because after computing the hash of the value, it refers to the exact bucket the element is placed into. Correct. And if you don't know what I'm talking about, please go ahead and watch the previous video in this list where I have explained actually everything about this. So I'm not going to explain everything again and again because it will be a boring part then. And why you will use unordered map? Because you want to maintain a collection of unique key value pair with fast insertion and removal. You don't worry about the order because you don't want them into a sorted order in any way. You just want them to be stored and key should be unique. That's what you need. So you will go for unordered map. Now let's look at this program here. As it is a map, I mean part of a map. So we need key and value type. And this is one of the way you can actually create or initialize your unordered map. And we access these elements using their key. So this is the object and we will use this syntax to actually get the value. So if you are putting this 1 means 1 is the key. So this is a key and this is value. So you will get A here, and in this case you will get B. So this is A and this is B. Now if you are updating it, means you are saying that now key 1 should hold C. So this will get replaced. So this will become C now. So if you will iterate over it, so this is a way we can iterate over it. So if you are iterating over it, this element object will actually hold two data, first and second. So first would be the key and second is going to be the value. So if you will print this, you will get 1, and in value case you will get C because we have updated it, and in second loop you will get 2 and you will get B here. And we can find some key whether it exists in that or not. So it is traditional way that you do dot find, and this gives you an iterator of the found value. I mean, if you have like this and maybe you have 2 here, then it will return the iterator of this guy. And if it is not giving the iterator of this guy, it will return some specific value which will actually be equal to this AND. So if you don't know what this AND contains, this contains some special value. So you have to equate that with this. So if that matches with this, it means it is not found. But here, if it is not matching, then we know that it is found and we can print it. So let's run this program and sum this video. I compiled it, compiled successfully. Let's execute this. And this is the value. See, I'm getting value A here, as I said, B here. And after updating, if I will print this, see, I'm getting, oh yeah, see, 2B is coming first and then A and C is coming because there won't be any order, correct? I said first it will be A and C and then 2 and B, but it can be in any order. And then you're trying to find 2 here and it is actually found, and this iterator will have first and second, and I'm just simply printing that, and that's it. And what if this is not unordered map? What if it is ordered, I mean map? And let's make this one as map here. So what if it is map? Let me just recompile this, compiled, and if I'll execute this, you will see the order. And let's see the difference. I'll maximize this and see the difference here. It was giving 2B and 1C, now it is giving 1C and 2B. So it is sorted on the base of key. I have an announcement for you guys. After completing 2 to 3 videos of STL, I will have data structure and algorithm videos
So maybe just wait for maybe 2 to 3 days and we will start on this again, because I have created some linked list related videos and linked list related problems. If you don't know, you can go ahead and see them, and maybe by the time you are watching this video, these lists are already created maybe. So go ahead and check it out. Thanks for watching. I'll see you in the next videos.
Hello everyone, this is Rupesh and you're watching CVP Nuts video series on STL series, and this topic is our set, and this is a container. And this is the syntax for this. Actually, this is not the actual syntax for this, but you can consider that it is a syntax. And this T stands for type. So whatever type you want, you can give. So for example, see, set of integers. Okay, so I'm passing integers here. So you might be wondering what is set. Actually, this set is similar to the set what you studied in your childhood. If there is a set, and let's suppose you have few elements like 1, 2, 1, 5, 9, 5, and these elements you want to insert into the set, then you will insert 1, 2, but this one already exists, so you won't insert this. So you will see 5, okay, you will insert 5, then 9, okay, then 5, but 5 is already there, so you won't insert that into the set. So this is a set now. Let's suppose this is S1. So similar thing happens in programming also. In programming also, your set, whatever you create here using this set container, does not allow duplicates. So you can see that from here to here, I have 1 to 5. After that, I am again repeating 1 to 5. Okay. And if you will print this using this for loop, all the elements in set, you will get 1, 2, 3, 4, 5 only. You won't get 1, 2, 3, 4, 5 and 1, 2, 3, 4, 5. And that example I will show you. But before that, let's go through this comments and we'll understand this container little better. So the first point is set is an associative container. So you know that set is a container, but this is associative container. So there are 4 associative containers in our C++ containers: set, multiset, and then map, and then multimap. So these containers are called associative containers. And what is associative container? It is a different topic. I should not go into that, but for your understanding, I'll say that in vector, you remember you have something like this, and you just insert values like 0, 1, 2 without associating these values to something else. Okay? These values are just going inside the data structure, and you are not associating this part to something else, this part to something else, and all that. There is no association here. But in case of these containers, whenever you put some element inside them, you create the association also. Okay, I would like to say this much only, and I'll undo this and we'll go back to this set container. So it is an associative container that contains sorted set of unique objects. Yeah, I just completely forgot about this sorted part here. This will keep your data into sorted order. And how it is sorting and all that, we'll see that when we are seeing the example. And the second part is it is usually implemented using red black tree. And I know so many people might be thinking, okay, what is this red black tree? It will come in data structure and algorithms video. When these C++ thing will get over, I will start on data structure and algorithm and we'll understand this better. But for now, you just remember that it is usually implemented using red black tree. Why usually means? Actually, standard is not saying that what data structure they are using underline this set, but people think that it is actually a red black tree. Okay, so you should think that, okay, it is using red black tree. Just keep this in your mind. And the insertion, removal, and search have a logarithmic complexity. Obviously, when there is a tree, you will have a logarithmic insertion, removal, and search complexities, correct? So fourth point is, if we want to store user-defined data types like classes, structures, and all that in set, then we will have to provide compare function so that set can store them in sorted order. Okay, so I'll come to this point when I am showing the or running this program. That time I will create a class and I will create an object of that class, and we'll see how to store objects, because here this is the example of storing numbers. Okay, and then we'll talk about this compare function. It's nothing just but the comparator function. Okay, if you know already that, it is good, but if you don't know, we'll see that. So the fifth point is, and this is the last point, we can pass the order of sorting while constructing the set object. So as I said, it will store the data into the sorted order, but in what order? So default, see, I have not given any order here. When I'm constructing this set, I'm saying that create a set with this type, and I'm not saying that store these data into ascending order or descending order. So remember this, default, it is ascending order, okay? But actually you can give the descending order also. So instead of this, you should just simply write it like set and then integer and comma, and here you will pass std : greater. So if you're passing greater after this integer, it will store this data into descending order, okay? And if you are passing std ... less, this is small s, less, then it will store in ascending order, okay? And by default it is less only. And last but not the least, it store unique elements and they are sorted in sorted order. Sorry, stored in sorted order. I got confused here. And you can sort in ascending or descending, okay? So let's quickly run this program and complete this video. And then I will show you how to store your user-defined data types inside your set. So before that, I would like to actually run this one and show you that it is working. So let's quickly compile this. It got compiled, and if I'll run this, see, it is giving you the output of 1 2 3 4 5. Can you see this? It is not giving 1 2 3 4 5 and again 1 2 3 4 5. And let me just change the order here. If I'll keep 5 here and let's suppose 3 here, then also the output would be this only, because it is going to store in sorted order. Compile, executed, see, your again output is 1 2 3 4 5. So you can see that it is storing in sorted order and it is storing unique elements. See, there is no copy. So you know, obviously, right, program don't know anything. It has to do everything by itself. So it will actually compare that, okay, it has created this, sorry, inserted this 1. So there was no 1 inside this set already. So it successfully inserted, 2 got successfully inserted, 5 got successfully inserted, 4, 3, till this place it got successfully inserted. But after this, 1 is going to be inserted and it will check, okay, 1 already exists. Then it won't insert this 1, okay? So that comparison is very easy because it is integer data type or integral data type. You can use character, float, double. They all can be just compared with less than or equal to or greater than sign. But when it comes to the user defined data types like this, let me just create a class here. I'll quickly create it. So when you have something like this in your program and you want to create an object of this and store so many objects of this type into this set. So for now, let me just simply remove this and create a set of what? Person. Okay, and we'll call it set equal to, and we are going to insert object inside that. Then I will take the help of initializer list 25 and name would be, call it Rupesh. You can have another object like 30. Let's make it Hitesh. Actually it is reversed. So let me make this 25 here and then here it should be 30. So that we can see it is actually storing in sorted order. Whenever we'll print, this Hitesh will get printed first, then Rupesh. But when we are inserting, we are seeing that this Rupesh is going first inside this set and then Hitesh is going, okay? And I can take some English name. Let's make this 22, John. I don't know, this is correct, right? Spelling is correct, right? Okay. And there is one error here because this E is not a simple integral data type now. It is
a user defined data type. So I would like to print e.age. See, it is giving me the type also, right? e.name, and I want to give some little space in between. Okay, it seems we are good, but we are not good. I'll explain why we are not good. I'll just compile this and it will complain for some reason. It is saying that I cannot compare it, that operator less than is an issue here. So it is saying that, dude, you are trying to insert 3 objects, 1, 2 and 3 inside set, and these objects are of type person, and I don't know how to compare to person. Really, I'm a computer. I really don't know what is this 30 Rupesh, 25 Hitesh, 22 John. So please provide me the comparator so that I can actually use that and come to know which is smaller and which is greater. So for that, there are actually so many ways to do that, and this is one of the way. You will say boolean operator less than, and we have to make it constant, and this is traditional constant person ref RHS, and here you will just simply return age less than RHS.age. That's it, you're done. And now let's compile and see whether it is working or not. Oh wow, see, it got compiled. Now if I will execute it, see, John is actually coming first, then 25 with Hitesh, and then 30 Rupesh. Actually, these objects are stored with the help of age, okay? And that is a very good parameter to sort them, right? And I have used age here. You can use anything with this comparator function, and this is a comparator function. And by default, this is being called. Now you might be thinking, what if I want to store descending order? A small trick would be, which is not a great or good trick, just do this. Instead of less than, you just do a greater than, and just save it, recompile it, and you will see the magic. See, 30 is coming, 25 and then 22, but this is not good practice. I'm telling you, you should create different function for this, and you should say that what function you want to use or what comparator you want to use when you sort it. Okay, so let's make this one less, and we can actually go for another function, bool operator greater than, and similar code. So I should just simply copy this and paste here. I should be a little smart, right? Okay, so instead of less than, we will keep greater than, and this is greater than, but this function has no effect because default is this. I told you, right? So here you can just simply say comma and std greater, and remember this, that this greater is coming from this functional header. Okay, so let's compile this. Oh, wait a minute, this will not compile because this is a template. Oh, what am I doing here? Okay, now, so this is correct. So this is the syntax. You have to use these brackets, and this is automatic type detection, but you can give explicit type also, that you want to apply greater on this type, but if you're not giving this person, then also it is okay. So let's compile this. Okay, it compiled, and if I will execute this, see, wow, it is still storing into descending order. See, now this time it is calling this one. Okay, and if I will make this less, let's make this less and save it, and again compile it and execute it. See, it is in ascending order. So this was descending and this is ascending. So this is how you use it. Okay, so hit the like button if you like this video. Don't forget to subscribe so that you can get the notification for upcoming videos like this, and I hope I will see you in the next videos. Bye bye, take care. Hello friends, this is Rupesh and you're watching CVP Nerds video series on STL series, and this topic is about multiset. So you might have seen set in my previous video, so this is about multiset, and it is slightly different than the set, and the difference is you can have duplicate objects inside multiset. So in set you will not have duplicate objects, you will have only unique objects. And this is the syntax. We have multiset and object name. So this T is for type, whatever type you want. So the first point is multiset is an associative container that contains a sorted set of duplicate objects of type. It can contain duplicate object. It's not like it always contains the duplicate object, but its speciality is it has the capability of set, but it can have multiple objects. Second point is it is usually implemented using red black tree, and most of the time I'm talking about the red black tree and all. Actually, this is a self-balancing tree. There is another tree, AVL tree, you might have heard in your college, or you might have implemented it. It was very easy, right? You have this and this and this, then you will balance this by bringing this one here. So this would look like this. So if this is 1, this is 2, and this is 3, then this tree will actually look like 2, 3 and 1. This is how it will look like. So this is the self-balancing tree. It will keep on balancing. It will see that, okay, if the depth is going to either -2 or +2, then it will try to balance it. So we're not going to discuss all these things because this is not a red black tree. I just forgot that. So just forget about this one. We'll see all these things when I will create a series on data section algorithm, okay? And then it will be a good fun. So for now, just concentrate on this topic. So the third point is insertion, removal, search have logarithmic complexity. Correct, because as I said, this multiset is implemented using red black tree, and if it is tree, then it is a logarithmic complexity for these operations. And if we want to store some user defined data, now concentrate, it is really very important because you don't always play with these numbers. You have user defined data types like classes and structures, and there you have so many data members, and then you have the object or the list of the objects of complex data type, and you want to sort it, or you want to keep them in multiset. So how you will do that? Because multiset doesn't understand the user defined data type. Okay, so we'll see. I have this user defined data type section here. We'll see all these, but first we'll take a simple example. Okay, I was reading through this one. If we want to store user defined data type in multiset, then we will have to provide a compare function so that multiset can store them in sorted order. Obviously, as I said, multiset will store things in sorted order, and that order you can decide either increasing order or descending order. Okay, so that's okay. But here the main important point is you have to provide a compare function so that if, let's suppose, this is an array of objects and the class type is person. Okay, and person can have data member like age and a name. Okay, so this is the class name and these are the member names inside that class. So on what basis you will sort your full array? Because this is one object, this is another object, this is another object. So you want to sort it. Then you need a comparator function. I'm taking this array example because it will be very easier for you to actually understand it. Otherwise, this multiset is not an array. It is kind of a tree. Not kind of, it is actually a tree. Sorry for that. Okay. So as I said, it is a red black tree and it is a self-balancing tree, or for short, you can assume that it is a binary search tree of some form. Okay. And to create this tree, it has to compare one object with another object. Okay, so for simple example, let's suppose there is no tree. You inserted one value, so that would look like this. That would become the root of the tree, and then let's suppose you're giving another entry inside multiset. Then that entry should go either right side or left side. Correct? So that decision has to be taken, right? Whether I should keep that in left side or right side. If I'm keeping right side, it means it is smaller than the root, and if I'm keeping right side, then it is bigger than the root. So that decision has to come, right? So in order to compare one function with another function, one object with another object, you need this compare function. And we'll see how to write a compare function. Don't worry about that. And the fifth point is we can pass the order of sorting while constructing the set or multiset. Sorry, I just forgot to write multiset here. What I mean is, see, you have this multiset. This is the object which is containing these many values. And if you notice, this 5 and 2 are duplicate. See, we have 5 and 2 here also. But when I will print this, you will notice that it is coming like this: 2, 2, 3, 4, 5, 5, 2 times 5. So this is how it will come when you will print this, or to say when you will iterate over this multiset. But the fifth point is saying that we can give the order of sorting, either descending or ascending. So we can specify the order after this type. So we can give comma here, and after that you will give that greater or less. So we can see all that. So I think you have understood the point. Now let's go to the compiler and run all these things. It got compiled successfully, and if I will execute it, as I said, see, it is printing 2, 2, 3, 4, 5, 5. Okay, so this is printing in sorted order. And I said that we can give the order of sorting here, right? So just give comma and then std less. So if it is less, and yeah, don't forget to hit this brackets also. Okay, so this is how it is, and inside bracket you can give the type of this one, but actually it works without this type also. So what I'm saying is that when you're comparing them, use less than operator. Means 5 is less than 2. No, it is not. Then you will sort it. So something like that will happen. Okay, so if I will compile this, there is no change. Let me show you that. See, still there is no change, but don't worry. See, it is 2, 2, 2, 3, 4, 5, 5. But if I will give greater here, then it will be reversed. Let me just recompile this, execute it again. See, 5, 5, 4, 3, 2, 2. So this is how it will work. And there are few other ways to actually populate your multiset. Like after this also, if you want to insert something inside this, you can have multiset.insert and give some value 20. Okay, so this is also possible. So let's compile this and execute this. See, 20 is coming before 5, 5, 4, 3, 2, 2. Okay, so this you can learn from any website and all. I'm here to actually discuss what else you can do with the multiset and how you will use it with user defined data type. So this is very important. Let me just comment out this code. So in this example, you will see that we have person and age and name, correct? Now we have two comparator function or compare function, less than and greater than, and here we have multiset object, and we have two objects, this one and this one, and it is actually similar to this one what we had here. Here we had number, we had integer multiset type, and here we have person type, so I'm keeping multiset as person, and we have these two objects of person. Okay, and this is what person would look like. It will have age and name. The important point is we need this operator, I mean less than and greater than operator, to be overloaded in order to make this multiset work. Otherwise it won't work. I'm telling you, if these two functions are not there, or at least one function is not there, then this is not going to work. And this greater means this should be there, and if we are using less here, means this function should be there. Okay, internally this multiset will actually call them depending on what order you are choosing here. So let's quickly run this also and see the results. So I'll just simply compile them again and run them. See, it is giving 25 and 20 because I'm using greater here. So it is sorting them in reverse order. Okay, and which person is greater and which person is smaller, I'm taking that decision based on their age. And I'm telling you, these things will be called when you are inserting these objects inside this multiset. So the points to remember is this multiset is very similar to the set, and it can have duplicate objects. I'm so sorry for this, but it can contain duplicate. Okay, you can see that if it would have been set, then it won't take duplicates. It will be printing only 2, 3, 4, 5. Okay, but as it is multiset, it will have duplicates. So don't forget to hit the like button, guys, and make sure you subscribe to my channel so that you can get the notification for upcoming videos like this. I'll see you in the next videos. Bye bye. Take care.
Hello friends, this is Rupesh and I'm watching CVP video series on C++, and this topic is about unordered set in C++, STL. So before going this, I would like to explain a set. So what is the meaning of set? So let's suppose you have these numbers 1, 2, these numbers or maybe again 5. Now if you are putting these numbers into a simple set, I mean std set, then I'll push this 1 here, I'll push 2 here. Before pushing 2, it will, check whether 2 already exists or not. If it exists, it will not push. So 3 is not existing, it will push. 1, yeah, it exists, so it will not push. 2, it exists, it will not push. Then 5, and then 6, and then 5. Oh, it exists, so it will not push. And maybe we are putting 0, so it will push 0. Now this is one property, that it contains the unique elements. Notice this, I am talking about set, not unordered set. So in order to understand this, what is this unordered set, you need to understand first what is set. So first thing is, it is unique. So if you have set of elements and you don't know how many times you have what, so what you can do, you can insert everything into one set, and you can be sure that okay, all the elements are unique in the set. Now you can iterate over this set and you are done. Now second property of set is, it is ordered data structure. When you will get the first element, we have 0 here, right? So 0 will be the first element when you will get it, because it will be coming as sorted order. So it will be like 0, 1, 2, 3, 5 and 6, like this. So remember these two properties, these are very important. Now let's come to this unordered set. So this unordered set have this property, it will contain unique elements. Now this is not there in unordered set because it is unordered. So you remember, if you are using set, how we used to write? We used to write std set. It means it is ordered set. So ordered underscore set is not there, it is just simply called set, but you can consider this as std underscore set. So these two are actually equal, but we don't write ordered set, we just simply say set. So it means it is implicitly ordered. So this was one important point, that it will not be ordered means it will contain unique elements, but when you will take those elements out, then it will not be in sorted order like how it was in case of set. Okay, so this ordered is not there with this unordered set. So this is the only or main difference. Now you might ask, okay, what is the use of this case then? Now let me tell you that. See, actually it depends on the requirement. Why you will go for set? Because you need both of these things. But sometimes you may only need uniqueness. You don't need ordered, because I just want to remove the duplicates of my whole list, because I'm having millions of data and it's just that I will use set and I don't have to worry about whether this already exists or not. There are other ways to do that, but we can use unordered set to actually remove duplicates. And we don't care about the order. I'm okay if it is not in sorted order. So 1 and 2 is there with set, and only 1 is there with unordered set. It's very clear? Okay, with this let's move to these points. So the 0th point, which is our first point, unordered set is an associative container that contains set of unique objects. Okay, search, insertion and removal have average constant time complexity. And why it is having average constant time complexity? Just because internally the elements are organized into buckets and it uses hashing to insert into the buckets. So if you know hashing, it will be very easy for you to understand that okay, it is constant time complexity, because hashing is actually a way to store the data and retrieve it very fast. So we use hashing for that. Don't worry if you don't know that. Anyway, you don't need to know the internals in order to use this ordered set. This is my interest, so I tell you all these things. And don't worry, I'll cover all those things in my data structure algorithm classes, which I'm starting after 3-4 videos. So hold on till that time. Okay, so this allows fast access to individual elements, since once a hash is computed, it refers to the exact bucket the element is placed into. Shall I give you the example a little bit? Okay, I'll give you the example. Let me clean this, and let's suppose you have these numbers. So they are 1.0, 3.1. So you can have any example. I have taken the float example. Now for hashing you need a hash function which will give you the key. So let's consider these are the values. So in my function, let's suppose I'm calling function and this is like a value. So first time I'll pass 1.0. Now this function, what it does internally, it takes whatever is there after this point, means for now it is 0 at first time, so it will return me 0. In that case, I will push this value into 0th bucket. Let's suppose we have these buckets here, 0. So I'll push this 1.0 into here. Okay, I'll get this 3.1. So I have the bucket which is 1 here. So I'll push the 3.1. I have another bucket which is 0.9. So I will have bucket number 9 and I'll push this 6.9 in that. And similarly, I'll have bucket for 2 and I'll put 9.2 and oh, wait a minute, I skipped this, right? So 8.1 will actually go here and 9.2 will go here, and as this is 10.0, so we already have 0, so this is 10.0. So can you see this? Now we have arranged our data into bucket. This is how it would be doing, I mean internally, not exactly in this order but something like this. I'm just giving you an example here. Okay, so now the storage part is done. Now you will query, right? And as I said, it will be a constant time lookup. So if I'm telling, dude, tell me whether this exists or not. Oh, I skipped this also. How can I do this? 4.2. Oh, let me count 1, 2, 3, 4, 5, 6, 7, 2, 2, 4 and 3, 7. Now it is okay. You guys might be shouting that I missed this, right? I don't know. Okay, so I was talking about how you will find that whether this exists in our data structure or not. So for this, what you will do, you will again pass this 6.9 to this particular function which will give you 9. It means it is telling that go ahead and look into 9 number bucket. So you will see that, oh, I found it in one attempt only. Otherwise, let's suppose if this list, I mean this data is arranged in this order only or maybe sorted order, then also you have to at least apply binary search, right, in order to get it. But here you got it in constant time. But don't think that binary search is bad idea. No, hashing has its own disadvantage. When the data grows too much, let's suppose it is millions and trillions, then in that case we have to rearrange all these hashing. I mean, we have to create different buckets and rearrange all these values, and that is a costly process. So I'm telling you, this data structure is always situational. In what situation you will use what, if you know data structure very well, then you can deal with this. So I hope you would have understood. So I have given 6.9 example. Let's suppose you are finding this 3.1. So you'll pass this 3.1 into this. It will return 1. And now you will see the bucket number 1. Then you're getting here. So this is also constant time. And maybe if you are finding 8.1, so 8.1 will also return 1 here, and you will see, okay, this is not my data, this is my data. So in second attempt you got it. So but still it is a constant time. It's not like you will keep on searching in the list. No, you are eliminating so much of comparison. So this is how typical hashing work. Internally it is little more than this, but I hope this is enough to understand what is hashing. I'm not supposed to explain you what is hashing here, but anyway I did. So this is how it works with the bucket case. So let's read this line again. This allows fast access to individual elements, since once a hash is computed, it refers to the exact bucket the element is placed into. So can you see our example here? Once this hash was done, now if I am searching something, I am directly going to that particular bucket, right, with these values. So here my function is returning whatever is there after this point, and I am making bucket on that basis, but internally what it is doing is not actually similar to this, okay? But the idea is similar. So with that, why unordered set? Maintain a collection of unique items with fast insertion and removal. This is the main point why we will use unordered set. I told you, uniqueness. See, this is the reason. So let's go to the program here, as it is saying that we can create our unordered set with these values, but see, 4 and 4. 2 and 2, 3 and 3. So we have so many duplicates. Now if I will say just print them, it will print not necessarily in the sorted order, but definitely duplicates will not be there. So let's run this and find out how it works. So compiled and successfully. So if I'll execute this, see, if you see the output, first it is finding whether this 2 exists inside this or not. And we can just simply compare that search as that object dot end. So if it is not equal to end means we did find what we were looking for. So I'm printing this. Now I'm iterating over this unordered set and see 3, 2, 1, 4. It is not in sorted order, but definitely unique elements. Can you see this? So as I said in the beginning, you will go for set when you want first and second both the property, you want uniqueness and you want sorted order. Then you will go for set. If you want only uniqueness, you will go for unordered set. That makes sense, right? With this, I would sum this video, but don't go anywhere without liking. I know you will forget. Thanks for watching, and if you're new to this channel, don't hesitate to subscribe because we have long journey, data structure, algorithms, and I'm sure you would love to know all these things. So consider subscribing. I'll see you in the next videos. Bye bye. Hello friends, this is Rupesh and I'm watching CVP Nerds video series on STL series, and this is about STD unordered multiset. So before this video, we have seen set and unordered set. And this video is about unordered multiset. So let's try to compare these three and try to understand what you will use at what situation. So can you see this? We have these requirements and let's see which one fills what. So in case of set, it will have both. So 1 and 2. What I mean is, if you are taking set data structure, it means you want both. All the elements should be unique and they should be in sorted order. So if this is the requirement and you're looking for the data structure, this is a good data structure. Another one is unordered set. So in this case, you will only have 1. 2 is not there because unordered means it is not ordered, means it is not sorted. So if you're looking for data structure where you want to store any object or anything which you want to be unique among all the numbers or objects, then you will go for unordered set. If you're a little confused, let me tell you that if you have 1, 2, 3 and again 1, this is your data, and if you'll push this data into set, it will only remain 1, 2, 3. This extra one will not be there because it contains only unique. So when you are going to push this one inside this set, it will see that okay, I already have 1, so it will not make duplicate. And sorted means it will actually maintain a sorted order. Now let's come to this unordered set. If it is unordered set and you are pushing the same data into unordered set, in that case it will have 1, 2 and 3, but not necessarily that it is in sorted order. It can be like 3, 1 and 2, or it can be 3, 2, 1. It can be in any form, but the guarantee is it will be unique. So this another or duplicate one will not come because it is going to check whether it already exists. So this is clear, right? Now come to this point. This is what we are learning now. This will not contain anything. These two properties are not there. Now you might be wondering why I'm going to use this. The point is, there can be a requirement that you have the list and you just want to store them like this, and your query can be, dude, tell me how many 1 I have. So it will tell you there are 2, 1. So don't think that if these two properties are not there, then it is of no use. No, it is of use, because if you want this behavior that if you are inserting 1, 2 and 3 and again 1 is coming, then you have to insert. Then in that case, you will use this one. Don't tell me that I can go for map also. Map can be the solution, but internally it uses a red black tree where the complexity would be log n, and here the complexity will be in some constant c. Okay, order of some constant, because unordered multiset also uses hashing. So both have their own advantages and disadvantages. But if you have such problem which is actually mapping great to this data structure, then you will not go for map. And I have written very important point, that why unordered multiset. So the answer to that is, it maintains a collection of non-unique items with fast insertion and removal. This is actually very important because it maintains inside the buckets and it uses hashing for that. So if let's suppose you have 1, 2 and 3, 4 and 5 and 6, just for example, and if I am telling that okay, remove this 3, what it will do, it will just simply remove from here, and this bucket will now only hold 4, and we are not supposed to touch this one and this one. But what if this is a kind of a tree, and this is how it would look like, right? Now if I tell you that, dude, delete some node, then it can create a big problem, because if I'm telling, let's suppose, delete this one, or forget about this guy, delete this one. Now this tree is actually binary search tree. Now it has to actually arrange itself in such a way that it maintains the binary search property. So it may have to do so many operations. But here we just simply removed it and we are not doing anything. And similar case with the insertion also. As this map would be a tree and you want to insert something, let's suppose there is 100 or 1000 height of this tree, and maybe you are inserting in between somewhere and it has to shuffle a lot, whereas here you may just simply come and push something in some bucket. Maybe if you're pushing 5, it may come here, that's it. You're not touching this bucket, you're not touching this bucket. So insertion is also order of some constant. Now there is another problem. Let's suppose you are keep on pushing the data in buckets, like as I said that we are using this unordered multiset here in this bucket case, and this is a map case. Now if you are pushing so much of data into the bucket, what will happen? The size of the bucket will grow too much. For simplicity, let's suppose you have only 3 buckets, like how I have shown here, and maybe you have 3 million records. Then what you will do, 1 million may come here, another million will come here, and another million will come here. I'm just talking hypothetically, don't take anything into account that it will be like this, because it depends on the hash key and what is the actual way you have handled it. But for simplicity, the general behavior, what it will do, it will divide this 3 million data into 1 million, 1 million and 1 million. Now if I'm telling, dude, tell me 5 is there or not. Now as you will pass this 5 into some function and that would give you the bucket number, now you will search in maybe either of the bucket, and as I have pushed 5 here, don't see this 5, it's just the mistake. There cannot be same element in different bucket, it's obvious. Now if you will find 5 here, you have 1 million data to search. This is the problem now. So in order to solve this problem, hashing will keep on checking, okay, am I getting too much of data? Then it will rearrange, and we have the option to rearrange all these buckets. So what you may do, you may have maybe 50,000 buckets, or maybe 5 lakh buckets or something, so that it is actually balanced. You don't have to search in one bucket too much. You understood my point, right? So in that case, this tree will be good. So it actually depends what is your requirement, so that you will choose the data structure. So I think I have talked too much about all these things. So let's go for the point now. And I hope you understood. If you don't understand anything, you can comment out, or just wait for some time that I will explicitly take these data structure and explain in my data structure algorithm series. There we will have more insight about all these things. So it's just a matter of waiting, guys. So let's see this. Now the 0th point is STD unordered multiset is an associative container that contains set of possibly non-unique objects. In that case, we have already seen that it can take multiple data, correct? Now the search, insertion and removal have average constant time complexity because it uses hashing and stores the data into the bucket, so it's a constant time complexity. Now Second point is internally the elements are organized into the bucket. This we have already discussed. It uses hashing to insert the elements into the bucket. That's what we have discussed so far. And this allows the fast access to individual elements because after computing the hash of the value, it refers to the exact bucket the element is placed into. That's what I said. If you are searching 5 and you're passing into that function, then you just have to search in this bucket or this bucket or this bucket. You don't have to search in all the buckets, correct? And it is good for fast insertion and removal. So with this being said, let's look at this program now. So this is a very simple program. We have so many of duplicate numbers, 4, 4, and maybe this is 2, and 3 and 3. So the ultimate result would be containing all the elements, but not necessary that they all will be in the same order, because it has to arrange them into different buckets. So if it is like I don't know, maybe 2 and 3 are coming together, and 1 and maybe 10 are coming together, or 3 and 9, sorry, not 3, 4 and 9 coming together, and so on and so forth. So now if this is the data structure, and if we are iterating over it, it will take the first bucket and give 3 and 2, and then 10 and 1, and then 9 and 4. So something like this may come, but it won't be in this order. Don't expect the actual order here. No, it does not maintain the order of insertion. Okay, so let's run this program and see the output. So let's compile this. It got compiled successfully, and if I will execute this, see, it was supposed to find 2, and this is very traditional way of finding something in the STL. You will say find, and you can get that iterator, and if that iterator is not equal to the end, it means you have found it. This is very old way. I don't have to explain this. Okay, so the important point is this guy. Can you see this? 10, 8, 9, 9. Yeah, okay. There is a catch here. Can you see this? 9, 9, 3, 3, 2, 2, 1, 4, 4. They are coming together. I mean, similar numbers are coming together because most likely they all are into same bucket. Not most likely, actually. It is the reason why they are coming like together. Okay. And as I said, we can do something like this also. Let me see out and set dot count, that I want to count how many 4 are there. So let's see if this one gives the output here. So I'll just compile this again and execute it. See, it is telling 2 times, means we have 4 2 times. So if you need this kind of data structure that you have so many numbers and you actually want to duplicate, I mean you want to keep the duplicate number, you don't have any problem with that, and you just want to say that, dude, count how many 4s are there, dude, find 2 is there or not. So if your queries are most likely like this and you are going to use them too much, then I would suggest go for this kind of data structure, because it provides you a constant time lookup and insertion, removal, and stuff like that. So the take home is, set is both unique and sorted. Unordered set is only unique, not sorted, and unordered multiset is not anything. It can contain duplicate and it is not sorted. But why you will use it? Because you want to actually keep duplicates and you don't worry about the order or something. And the reason you are using this because you want fast insertion and removal. Okay, and I think you have liked this video, so don't forget to hit the like button, guys, and make sure you subscribe to my channel so that you can get the notification for upcoming videos like this. I will see you in the next videos. Take care. Bye bye. Hi, welcome back. This is Rupesh and you are watching CPP Nuts video series on STL series, and this video is about stdq. So yesterday we saw a deque, and before that we saw map, set. So we have covered so many things. Now this is the time for q. So if you're thinking that we have this stdq to solve our traditional q problem, then you are correct, because let's suppose this is your front of the q and this is a rear part. So we have studied q in our data structure and algorithm classes, and what is the point of learning this data structure? Actually, it is a FIFO data structure, first in first out. So the point is, whichever goes first will come out first. So now can you see this? C++ have solved our problem. Here, can you put any data type? Yes, it can have any data type like user defined data type. It can have vector, map, you can imagine, right? Why I'm emphasizing on this, because the biggest problem was to implement queue for different data types. So now you can have the same queue and just data type you have to provide and it will work for you. So the point is, stdq class is a container adapter that gives the programmer the functionality of a queue. And the functionality of queue means you can use these functions, like you can push, but it will push only in the rear part, and if you're popping out, it will only pop out from the front. So this is what the rule of the queue is, right? It will check whether it is empty or what is the size of it. You can actually access the element. Let's suppose it is 1 2 3 4 and 5, and we have further. So, and for now just assume that this is the last element. So if you will do front, you will actually get this one, and if you do back, you will get the last one. Don't tell me that in queue you can only get the first one. Actually, in queue you can pop from the front, meaning you can only remove from the front. Removing means this one will no longer be there, but you cannot remove 2, 3, 4 or 5. You can only remove one. So this is the rule of this data structure. Okay, but you can access the element of queue only if it is front and rear, because you have these two functions, front and back. And the next point is queue is a FIFO. That's what I said. We all know that. Second point is stdq provides only specific set of functions. Yeah, these are the functions it provides. And stdq allows to push, means insert, at back, and pop, meaning remove from front. So let's go to the program and see how it works. So if I'll compile this, compiled it, compile successfully, executed. Okay, I have not. Oh my goodness, I have just forgot to call this print, right? QUE. Okay, I don't know why I forgot this. I mean, how I forgot this. See, we are getting ENDL. Let me compile this again and execute this. See, 2, 3, 4. So you have created queue object and now you can push. So if you are pushing 2, 3 and 4 in this order, then 2 would be in the first place, this is going to be the second place, and this is going to be at the third place. So that's how we are getting here, right? Now this is very important. Don't think that you can iterate over queue like how we do in different containers. No, it is not like that. Now pay attention. It is actually, you have to get the first element, because you can only get the first element or remove the first element. So what I'm doing is I'm printing the first element, because front will give me the first element of the queue, and after that I'm popping out. So as I said, this will remove from the front. So once it is removed, now queue front would become 3 now. Okay, before it was 2. So it will check that, okay, queue is empty. No, it's not, because I'm putting this condition here, will still come inside, and now this time if I'll put front, it will give me 3. So that's how I'm getting 2, 3, 4, and after popping out the last element, which is this one, I will obviously have list as empty, and this loop will over. So this is how you actually iterate over queue. You don't have that traditional, like you can iterate over the map and all those container like vector or set, but this is different. Okay, so you have to remember this. So now if you ever need to use queue, you will always go for stdq. You will not implement your own queue, because these functions are well tested functions. So it's not needed that you should go for your own queue and implement your own stuff. We can use these library provided data structure and we can speed up our coding, right? So with this, thanks for watching, guys. And don't forget to hit the like button and subscribe to my channel if you are new to this channel, so that you can get the notifications for upcoming videos like this. I'll see you in the next videos, guys. Take care. Tada. Bye bye. Hello friends, this is Rupesh and I'm watching CBP Nerds video series on STL series, and this video is about priority queue. Have you ever heard about min heap or max heap? So this is what it is. And let me tell you that I'm not going to explain what min heap or max heap is, but I will tell you what is the basic functionality of this and how we can achieve the same thing with this priority queue. So in order to understand this, first you need to understand the requirement. The requirement is, let's suppose you are keep on getting some data and you have to store that data somewhere. And while it is incoming to store the data, sometime it may be required that you have to get the data from here, and it should be either maximum of all the data what you have received so far or minimum of all the data. So let's suppose so far if I have received maybe 5, 10, and if I will say that okay, I am building a min heap using this priority queue, and if I will ask give me the top one, it will give me 5 because it is min heap. I am maintaining a minimum heap. And if I'll ask for the max heap, I mean if I want to create a max heap, and if I will ask the data give me the top one, it will give me the 20. So the requirement is you keep on getting the data and you are inserting that. This could be a very big list. This can be in millions. And the requirement is while you are inserting, sometime you may have to retrieve the maximum or the biggest or the largest element out of all the million number. And once you received it, you may delete that or you can just access it and keep on inserting the next data. So if this is your requirement, then the priority queue is the solution for you. Actually, internally it is a implementation of a min heap or max heap that I will explain in my data structure series. So this is an STL series where I will explain STD priority queue. So this is clear, right? I mean, you will make a data structure, or this is kind of a container which will contain all the elements for you, and whenever you ask, it will give you the topmost or the smallest element in order of 1. This is what our requirement is. Okay, so with this, let's go ahead. So what is this? I explained you all this. So node number 0 is STD priority queue is a container adapter. Again, it is a container adapter. It means it is not any kind of a container. It is adapting a container, and that is a vector here. So it does all the things using this vector inside it. So STD priority queue is a container adapter that provides constant time lookup of the largest or smallest element. This is very important. It is a constant time lookup. And the second point is, by default, vector is the container used inside this. Second point is, cost of the insertion and extraction is logarithmic. Exactly. Now you got the point, right? Internally, it is maintaining some kind of a tree. Don't tell me that I'm telling you internally it is using vector, and now I'm saying it is using tree. No, actually, vector is nothing but an array, right? Kind of this. Now, actually, you can convert this array into binary search tree. So we'll learn all these things. Don't worry when I will explain the data structure videos. So for now, you just understand that internally it is using vector, and that vector is used as a tree. That's why the cost of insertion and extraction is logarithmic. And the third point is STD priority queue is implemented using make heap, push heap, and pop heap. So if you don't know about these functions, actually this make heap will take an vector and convert that into heap. So we don't have to worry about these functions. I have listed them just because you should not feel that okay, magically how internally it does that. So magically doesn't happen anything, right? So internally it uses make heap, push heap, and pop heap to actually maintain a heap inside priority queue data structure. And this priority queue data structure is very important. Don't forget the requirement, guys. I'm again and again telling you, I'll tell you again. The point is, you will keep on getting the data. See, you are getting data not simultaneously, one after another, and you are pushing that into some list. So now if I ask, okay, you have received maybe 1,000 elements so far, give me the biggest one in your list. Then you have to search and go, maybe n would be the complexity, because you have to go to 0 to maybe n. And this is a very complex process. This is not a good process. Okay, this is not good process. Oh, this is very ugly face, because this is going to be very ugly. Okay, so what if we can maintain this in some way that if I ask you give me the biggest one, you will give in order of constant time, let's say, not this order of n, because this n can be million and trillions, and then it will be a big problem for you. So that's why we manage our data using this priority queue, which internally creates a heap. So don't worry if you don't know about min heap or max heap. These things will come later in this channel. So let's say this program, how it works. So this is your driver function. We have main here. So this is how we create a priority queue. You can write it like this is the data type. You can use any data type, and if you're using non-integral data type, I mean your user-defined data type, then you have to give comparator. So that is very common nowadays, right? You should be knowing how to give the comparator. If you don't know, I'll give you this example. So the first example is this one, second example is this one, and this is going to be a third example. So the first example, we can see that, okay, we have created the object. Now using for loop, and this is an array, and one by one, first I will get this 1 inside this element, and I'm pushing that element into the queue. So as this is priority queue, internally it is going to use what function? See this function, push heap. So when it created the heap, it will use make heap. When you are going to insert something into the heap, it will use this function. If you are going to extract, I mean remove something, some element from heap, it will use this pop heap. So everything happens on the top. It doesn't go inside. If there are so many nodes, so it will not go inside. It will always work on this top, because among these 5, 10, 15 and 20, this 20 will always be there. If it is max heap, maybe 15 is there and 10 is there. Something like this would be there. But it is very much clear that if it is max heap, the topmost would be the maximum element. If it is min heap, its root will be the minimum element among all the elements. So as it is tree, we know that, okay, it will get into this tree data structure and will get the element at root. Okay. Now, as you have inserted this full array into your priority queue, if we will print it, this will not get printed in the same order. It is actually going to print in sorted order, because I'm calling this print queue, and this is how we actually print it. We check that priority queue is not empty. You will get the top element and you will print it, and you will pop the element which is again a top. So top one will get removed, and then it will adjust itself to find a new top or the new maximum or new minimum value among all those, and that would become the top now. So if that is happening in loop, you will get these numbers in descending order if it is max heap, and ascending order if it is min heap. And similarly it will be doing the same thing here, because we are not doing anything extra. We are just saying that use container as vector, and I'm going to give you the comparator here, I mean, or just a way of telling that, okay, now don't go for descending, go for ascending. So if you are putting greater, means two elements will be compared with greater than value. If you're not putting this, the by default is less. So two elements will be compared with less element. So if, I mean, less operator. As we are not giving anything here, we have less here, then in that case it will be in descending order. So this will print 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. So it will be printing like 9, 8 till 0. So this is going to be descending order. And as we are saying that compare with the greater, it will be an ascending, so 0 to 9. And this guy I have taken because I wanted to show that you can actually use your own comparator, and this is how you will use it. You can pass your comparator when you are actually creating the priority key object, and this is the syntax for that. And similarly, you are pushing the same data into this, and this time it will use actual visible function. So you can have any data type here, and depending on what data type you are passing, you can compare here on whatever parameter you want to compare for those data types. So it's like you can pass different objects and you can actually compare them. So this way you can compare user defined data types. So let's run this and sum this video. So if I'll compile this, say it got compiled, and if I'll run this, see, this is the output. So first is 987 till 0. So this is going to put these values, and as we are iterating over it, we are always removing. So that's why it is printing in the descending order, because you are removing the top one. So next top would be the next greater one, then next greater one, like that. If you know what is min heap or max heap, then actually this is going to be a max heap here, this is going to be a min heap, and this is also going to be a max heap. And if you don't know what is max heap, min heap, don't get confused or don't think that you don't know that, because I'm going to explain all those things in couple of days, because this STL and all these threading and everything is getting completed. So I have already started my data structure classes, but few people said that okay, I have not completed C++ stuff totally, so I fall back and now I'm about to complete the C++ up to some extent. Then in maybe 10 or 15 days I'll go for the data structure and algorithms, and there you will get everything, don't worry. So with this, if you're new to this channel, consider subscribing it because you will get the notification of upcoming videos like this, and put the like and comment what do you feel about this video. So with this, thanks for watching guys. I'll see you in the next videos. Bye bye. Hello friends, this is Rupesh and I'm watching CVP Nerds video series on STL series, and this video is about STD stack in C++. So if you are thinking that this is the exact stack what we studied in our data structure algorithm classes, then you are actually correct. And this is your stack LIFO, correct? Last in, first out. So whatever goes last will come out first. So what I mean is I inserted 1 before, then 2, then 3. Now if I want to take out anything from this stack, and as I said, this is a stack, so I will take out 3 first, then 2, then 1. So it's like you go into the parties, right? So there are stack of plates placed one top of another, right? So this is kind of a stack. So can you imagine, let's suppose this is your table, and if someone is putting a first plate, this is your first plate, this is your second plate, this is your third plate, and this is fourth plate. So which plate was kept first? Obviously this one. So when they was arranging, they put this one first, then this one second, this one third, and this one fourth. Now if you go and want to take a plate, you will take this plate out first, then this one, then this one, and then this one. So this behavior is a stack behavior. And this particular thing is used to solve so many problems. I can tell you this is one of the important data structure. And now if you want to use this data structure in C++, you can use it. So let's see what are the different points about this data structure. So the first point is stack class is a container adapter. Yes, before this we learned stdq, and that was also a container adapter, and that time I missed to tell that what is the meaning of this container adapter. You might have seen container, iterator, algorithm, but what is this container adapter? Container adapter means it is not a container. It is adapting some existing container and mapping the functions, like these are the functions, right? So this std stack will have these functions. So internally inside this std stack there is another container, and by default that is deque, which we have already studied, and you can actually modify this. So now you understood. Stack itself does not have its own internal structure. It uses deque for internal operations, like to create a array so that it can place it. So internally it has to use some functionality, so it is using deque. And as I said, you can change it, you can make it vector if you want, but that's okay. You should use deque because deque doesn't double the size once the existing array is totally full. Okay, so I have already explained how this deque works internally. So if you don't know, you will get the link in the description field. I have so many lists. You just go for the STL list, you will get this video. Okay, so first point is internally it uses deque STL container that we discussed already, and it is a LIFO, last in first out. Yes, that I explained you here. And fourth point is, third one, std stack allows to push. And yeah, this is very important. If you have not seen what is called stack, it is like we have some place and we keep on pushing the data. Let's suppose we have a list of the data, maybe 5 and then 10, then 2. So we'll push it like this. We'll push 5 on top of that 10 and 2. So this is push, and push means insert and pop means remove. So push is easy, like you will just keep on doing this. And let's suppose you want to pop it. You cannot remove 5, 10 and 2. You have to only remove 3, then only you can remove 2 and then 10 and then lastly 5. So this is the order. You have to always go from top, like how we do in the parties. Like we have stack of plate and you always remove the top one. You don't go for the third one or maybe first one. We always take the last inserted plate. So I think you have already understood this. So these are the functions we have in stack, Empty means it returns whether the stack is empty, and I have copied this from internet, so you will get it if you will Google. So size is like returns the size of the stack, correct, because how many elements are there inside the stack, it will give you that. And again the complexity is order of 1. Top is return a reference to the topmost element of the stack, and the time complexity is again order of 1. What is this top? Actually, when you have this stack, you will always have one top variable or pointer which is actually pointing to the last guy in the list or in the array or whatever we are using to actually implement stack. But the point is the last one is always at the top, and this top pointer will always point to that guy. So if you will get this function, it will return this one, last one, and push, and this g means some data, adds the element g at the top of the stack. So that's what I said. We keep on pushing the data on one top of another, right? And the pop is correct. Delete the topmost element of the stack. So there are two important terminology, actually three. These three important terminologies. So top will actually give you the element, it won't do anything in the stack, and push will actually insert the element, and pop will actually delete the element from the stack, and the topmost will get removed. So with this, let's see this program and we'll sum this video. So if I'll compile this, it got compiled successfully. Now let's execute this one. So the important point here, notice that I have a stack of integer type. Notice this, and this is a variable. I'll keep on pushing so first I pushed 2, 3 and 4. So currently 4 is at the top. Now if I will say print, so I'll come here. Now it is very important point. Notice guys, you cannot iterate over the stack or queue, what I said yesterday, right? So in order to iterate over it, you have to actually remove the elements. So in queue, we used to remove element from the front, but here we'll remove the element from the back. So this is how we do it. We check whether this stack is not empty. If it is not empty, we'll print the topmost guy, which is 4 in the beginning, and then we'll pop one element, means 4 is popped out. So we have removed 4 from the stack, and then we'll go back. Stack is still not empty. We'll come back, and this time top is 3, and then we'll remove 3, and similarly we'll print 2 and we'll remove 2, and lastly stack will be empty and we'll come out from here. So this is how we have to actually go with this stack. And one more thing guys, I was telling you that you can overload this, right? So std vector, and this vector would need the type, correct? So now if you will compile this, okay, what is this? Oh yeah, I just forgot this. So vector of integer, because you are passing stk, which is type of not only integer comma vector. So let's save this and compile this. Okay, compile successfully. Let's execute this. See, there is no change. 432 this time, and if you'll see before, this is also 432 now, but internally now it is using vector. But I know you don't see any difference. Internally there is a difference. So this is important. You have to know the internals of the vector and the deque, which I have already explained in my previous videos, which you will get the link in the description field. And if you know that difference, you will be able to actually use the correct data type for the container adapter, because this stack is a container adapter, and you are giving the container type here, that what container you want to use here. Don't go without hitting the like button. So thanks for watching guys, and if you're new to this channel, please subscribe so that you will get the notification for upcoming videos like this. I'll see you in the next videos. Ta-da, bye bye, take care.
Hello guys, this is Rupesh and I'm watching CPP Net video series on STL Algorithm series, and this video is about copy and copy if function. So many people don't know why you will use copy function. I mean, I can understand what is the use of copy if, but I don't understand what is the use of copy, because I can just simply assign one thing to another thing using assignment operator. So we'll try to understand all those things in this video. So let's start this. So the notes says that copy copies the element in the range defined by first and last to another range beginning at some place. Okay. And second point is about copy if. Only copies if predicate returns true, meaning you can set a condition that I want to copy this array or this vector or this container to another container only if some condition satisfied, and you can pass that condition
and it will take it as a predicate. So first of all, I'm creating a vector here, which is a from vector, meaning we'll be using this vector to copy things here and there. Okay, so I'm preparing this from vector. Its size is 10 so that it can hold 10 elements, and I'm using this iota function which will insert from 0 to 9 inside this vector. So this is what this iota does, and I have created a video for this one. If you don't know what is the significance of iota function, you can watch that video. Now going forward, see, we have two vectors, so we'll be copying from vector to vector 1. So one way of using copy function is like this. You create a copy, you write a copy, you say that from vector begin and from vector end, meaning how much you want to copy to this vector. So this is the syntax. You will give start and end of the source vector, and this will be the destination vector. That's pretty simple. And I'm using this print function so that I can just simply print it. So this is printing it. It's some fancy way of doing the same thing. Or alternatively, you can do this. Copy, same, begin and end, but this time you will use this back inserter. And if you are using back inserter, you do not have to have the size of your vector initially like you had this one, because you had to create this vector along with the size, meaning at least this much size should be there for this vector to actually hold this one. But here, if you don't know how much you are going to copy and you don't know how much you should allocate the memory for this vector to, you can just simply use this way. Cool, right? And then I'm printing that again and see. Now this is what people get confused. Either way is equal to this, meaning either if you're using this way or you're using this way with the back inserter, both the things will do the same thing if you're just simply doing this. From vector to vector. Just assign from here to here. So now, what is the benefit of copy function if we can do this? Correct? Actually, the copy function will look similar if you are using it like this. Begin and end. But the advantage comes when you want to say that from begin plus 2, meaning it will start at this place, what you cannot do from here, with this one. And here also you can say and minus, let's suppose 6 or something, then it will copy that much only from this vector, but here you don't have that facility. Now it's very easy for you to actually digest that why you will use copy function when you already have this mechanism to assign one thing to another one. Okay, let's move to this copy if, and then we'll be done. So this is actually similar, like from vector you will say start and end. So this becomes your source now, and this is going to be your destination. Now this is the predicate. So you can use a lambda function here. So this lambda function will be called each and every time when you are copying from vector to vector. And if you are returning true, meaning it will copy. If you are returning false for that number or object for that matter, then it will not copy into the destination vector. So let's quickly print this and see how it is working. Hey guys, time for a quick pause, and what you're seeing right now is my Patreon page. So if you don't know what is Patreon, it's a crowdfunding website where you can support any content creator like me, and in return you get rewards. So if you join me, I can be your private tutor, or you just want to chat with me and ask your doubts, or maybe you just want to support me with very small amount and I'll still have something for you. So do visit my Patreon page and see if you like it. And if you want to discontinue anytime, you can do that. So if you have already visited my Patreon page, let's continue our video now. I executed it. See, this first print is printing from 0 to 9. That's what it will do. Second also, I told you that it is similar, so it will do the same job. But third one, see, odd numbers in the vector are, meaning I'm copying odd vectors. So if x modulo division 2 is equal to 1, meaning this is odd number, then only it will become true. But this is really a costly process to do this. We can just simply do this AND operation with 1 here, and you will get the same result. Let's compile this and execute this. See, it is still 0 to 9, 0 to 9 and 1, 3, 5, 7, 9.
And this is really very faster way to actually find whether something is odd or even, because this will check the last bit, and if it is odd it will be 1, and if it is not odd it will be 0. We don't have to check any other bit, it's just the last bit. So thanks for watching, and I know I was not giving videos for almost 50 days because I was so busy, and now I have scheduled some separate timing for this, so now we can expect continuous video. So thanks for watching guys, bye bye, take care.
Hello everyone, this is Rupesh and I'm watching CPP Net video series on STL Algorithms, and this video is about copy n and copy backward. So the first point says about copy n function, which is used to copy given number of elements from source to destination. So this is pretty clear that you will be copying n numbers from source to destination. It should not be very hard to understand this. So we have this from vector where we'll create this vector. So we have filled 0 to 9 because this vector size is 10. So we will fill from begin to end from 0 to 9 because it can hold only 10 elements. So once this from vector is prepared, we have to vector 1. There we will use copy n, and from vector from begin we are saying that copy 4 elements and insert into to vector 1. So it will take 0, 1, 2, 3 and put it into to vector. So this is pretty clean that okay what you're doing, but copy backward is little confusing. So this time I have taken vector 2 with 15 size and I'm saying copy backward, and this is the syntax. You will begin and end the whole vector of your source vector, and you will give and of your destination vector because you want to insert from the backward. So it's not like it will reverse or something. No, it will start inserting from backside of your from vector to backside of to vector, meaning it will take the last element of this one and put in the last here, and then it will go to the second last of this one and second last of this one, and it will copy again this second last into this second last, and it will keep on happening until unless this guy reaches to the beginning of this from vector. So if you notice here, see our from vector is of 10 size, but my destination is 15 size. So it will be very easy for us to understand what is happening. So let me just quickly print this.
Hey guys, time for a quick pause, and what you're seeing right now is my Patreon page. So if you don't know what is Patreon, it's a crowdfunding website where you can support any content creator like me, and in return you get rewards. So if you join me, I can be your private tutor, or you just want to chat with me and ask your doubts, or maybe you just want to support me with very small amount and I'll still have something for you. So do visit my Patreon page and see if you like it. And if you want to discontinue anytime, you can do that. So if you have already visited my Patreon page, let's continue our video now.
And executed. See, for first I said it will be copy only 4 from vector to to vector. So 0, 1, 2, 3. So there are 4 elements it copied. Backward did this. It copied into the to vector but from backside. So it is like, for example, if you have 1, 2, 3, 4 and 5, and this is your source, and let's suppose you have destination with some size. Let's suppose 0, 0, 0, 0 and 0 and 0. Okay, so let's suppose you have 0, 1, 2, 3, 4, 5, 6, 7 size in the destination, and you have 5 size for your source. So if you're copying from here to here, meaning you will copy this 5 here first, and then 5, and then you will copy 4, and then it will be 3, like that, 2, 1, and it will copy nothing here. Okay, so this is how it will copy. So it will start from the backside of both, from here and here. Okay, so it was a little confusing in the beginning, but now it is clear, right? So there is nothing much in this video, so let's sum this up. Thanks for watching guys, bye bye, take care.
Hello guys, this is Rupesh and I'm watching CPP Net video series on STL, and today's topic is STD deque.
and this is called double-ended queue. Don't get confused with this queue with what that std queue is. So this is deque, not std queue. Okay, so that stack and queue, so this is not that queue. Okay, this queue is little different than, not little different, it's totally different than this double-ended queue. If you want to compare this with some data structure, compare it with vector. And why, we will see that. So we'll go to these notes line by line, and I'll try to cover all the important aspects of deque. So be with me till the end and have fun. So the first point is std deque is an indexed sequence container. So we have vector also, which is an indexed sequence container, because we have, let's suppose, VEC, and we do this, right, 0 or 1 or 2. So this is an indexed base sequence container, and the reason is vector inside have an array. So you know that std vector is a class, and inside that it maintains an array. So whatever you pass it here, it actually get it from that array and return you. So the time complexity is 1 for vector, and that is indexed container. deque is also indexed container, but wait a minute, this is little different. We'll come to that. So the second point is it allows fast insertion at the both end, like beginning and the end. You remember vector was only having push back and it was not having push front, but actually this double-ended queue will have push front also, and it will have pop front, whereas vector don't have anything like that. Vector will always allow insertion and popping out from the rear end, not the front. But if we'll talk about deque, it will allow this operation here also. Okay, you can do from both the ends. So this is one of the difference. We'll see how it actually does that. Okay, it will come in between. Now third point is, this second point is, unlike vector, elements of deque are not stored contiguous. This is very important. Now let's try to understand the heart of this deque. So concentrate well. So as I talked about this vector and the property of the vector, I said inside that it will have one big array. Okay, let's suppose this is how your array is looking like inside vector, std vector. Okay, we are talking about std vector. In deque, the point is we will not have only single array, we will have multiple arrays, and they will be actually linked to each another. And what is going to be the size of this array is fixed. We will see that size. I have noted down that point also. But the current point is vector will have elements stored in sequence. But here we have several arrays. So in case of vector, let's suppose V, if I will ask 2, then it will take this 2 and see into this vector, and this is 0th position, 1st position and 2nd position, and this will return this data to me. It is that straightforward, okay, for vector. But let's come to this deque. It is deque. Let's suppose this is having only 4 elements. So all the vectors will have 4 elements in it. Let's just assume it, okay? And let's suppose you want 6th element. So let's suppose you are doing deque of 6th. Then it will actually know that, okay, one array is having only 4 elements. So how much extra element I have? So it's just that it has to divide this 6 into 4 and 2. So this much it will skip, and it will get the second element from this array. Okay, so this one is skipped because we know that it will have 4 elements and it will take this element, because this is going to be 0, 1, 2, 3, 4, 5 and 6. So 6 means actually it is totally 7, because our indexing start from 0 to 6. So this is totally 7. So forget about this one. So 7, if you want to break into 4, and then it will be 3. So this is going to be 1, 2 and 3. So this is what we are looking for. So this is what it is doing internally to actually get your element. But in vector, I told you it is just one dereferencing, but in this case it is 2 time dereferencing. First you will dereference the particular array, which is this one, this one and this one, or this one. Then you will dereference the actual element. So anyway, even that is also order of 1, because two-time dereferencing is not that bad if you really need a deque data structure, because in case you have to insert in the beginning and the end, if that is what you need, then you have to go for the deque. So let's move to another point. This point says it uses individual allocated fixed size array, that's what I said here, with additional bookkeeping, meaning index-based access to deque must perform two pointer dereferencing. That's what I explained here. But in vector, we get it in one dereferencing. Correct? We all know that. Now let's move to this point. The storage of a deque is automatically expanded and contracted as needed. Obviously, let's suppose we have all the elements 1, 2, 3 and 4 and 5, 6 or 7, and let's suppose I started popping out from the front. So this is gone, this is gone, this is gone and this is gone. Then it will know that okay, this array is actually empty. Now what will happen? We will end up deleting this array and we will start pointing this array. So can you see this? We are shrinking now. So this is what this point is. Now fifth point is expansion of deque is cheaper than expansion of vector. This is really very important. Again, listen to me carefully. So the point about vector is, let's suppose initially when you create a vector, it will have very small size. Okay, and you keep on pushing the data, and once it will see that okay, now I don't have any space to push another element, what it does, it creates a double size than what it has currently. So if it is 4, then now it will be 8, and what it does, it copies these elements one by one. So this copy is very costly process and it takes so much of time. That's why I'm saying that expansion of deque is cheaper than expansion of vector. So this is what the expansion is. We are expanding our vector. So to expand that, let's suppose now we have only 4, but let's suppose it is 400 or 4000 or maybe 40,000. Then you will have to copy all that 40,000 into newly created array, which will be having 80,000 capacity, because it will get double and this capacity was 40,000. So can you see this? You end up copying 40,000 and this is a waste. But in this case, you don't have to copy all these things. What you have to do is you have to just append extra array. That's it. And you will then link it one after another. And if you need more, you will go for another array and then another array and another array. So you are not copying anything. You are creating new array, because now we have chunk of the arrays. So we have this facility here. But to maintain this chunk of array, we have to do little bit of extra than this vector. And it is obvious, right? And this is really very important point about this. So let's move to this sixth point. deque holding just one element has to allocate its full internal array. And the size is, example, 8 times the object size on 64-bit libstd C++, or 16 times the object size, or this much byte, whichever is larger. So if you did not understand this point is very simple. It is saying that when you are creating a vector, let me erase all these things. Okay, this is saying that when you create a vector, initially its internal array size is 0, then it becomes 1, 2, 4, 8, something like this, because you keep on pushing the data. But in case of deque, you have to have at least some amount of array. I mean, that array size should be of some length, but not 0 or 1, because this is what the standard size is, because we have to maintain several arrays, right? So the size should be equal. So they have decided some size here. So even if you have one element, you have to have at least one this much big array. But in case of vector, it won't be that case. So if you have very few elements, creating vector would give more advantage than deque. But then I would say that where you even going for vector, you go ahead and use directly array, correct? Okay, so now let's come to this time complexity. Random access inside deque is order of 1. That's what I explained. It has to dereference 2 times. One time the array and another time the element in the array. Now another point, insertion or removal of elements at the end or beginning is constant. This is the important point. See, let's suppose this is your front here and this is your back of your deque, and let's suppose this is actually filled. Every element of this array is having data. Now if you are inserting in the front, what it has to do, it has to create another small array and just have to link it. That's it. And now front will actually point to this guy. And what you can do, you can simply push the element inside your newly small array. So that's why it is constant time. But this constant time is either from the front or from the back. But if you are inserting or removing the elements not from the end or beginning, in between some element, then it is linear, because then you have to shift the data. Let's suppose you are removing, maybe there is one data here and you want to remove it. Now whatever is coming after that, you have to shift everything. So that's why it becomes linear. I mean, in case of removal. And maybe if you want to insert something in between, maybe here you want to insert something and something is already there, then what they have to do, they have to shift it. So that is also a linear job. So that's why it is a linear process. So enough theory, let's go to the practical now. So this is your program. Let me just compile it. Compile successfully and let's execute this. Okay, fine then. See, now the beauty of this guy is we have push front. Push back was already there in vector. Now we have push front. So your initial deque is 2, 3, 4. Now if you will push front 1, then it should be having 1 here. And if you are pushing back 5, 5 should come here. So that's why it is printing 1, 2, 3, 4, 5. Okay, and printing is this function. It is very simple that I'm just iterating over this deque and just printing it. And in second case, I have the same deque and I'm doing pop front and pop back. So this will go off and this will go off. So only remaining thing will be 3. So can you see this? So now you might be asking the question that, okay, where I will use this? I mean, what is the actual use of deque? Now, let me tell you that if you have this kind of problem, like you have to insert to AND or to front, then you should go for deque, because this is a indexed based sequence container. It will be faster and your both the needs are getting filled, that you want to insert from beginning and from the end, or you want to remove from the beginning and the end. So this is the data structure for that. Okay, wow, it was good, right? You learned something new today, correct? Yeah, even when I saw this data structure, I was also very happy. So thanks for watching, guys, and don't forget to hit the like button, guys. And if you're new to this channel, consider subscribing if you want to get the notifications for upcoming videos like this. Okay, tada, bye bye.
Hello everyone, this is Rupesh and I'm watching CPP Net video series on STL Algorithm series, and this is the second video of this series, and this is about sorting in STL algorithm. So I just forgot algorithm. So it's actually the similar function what we know, but I would like to say few more things about this function which is really very important. So I mean, how it can be handled, because we have parallel processing, meaning multi-threaded way of sorting is also available into the STL algorithm, which so many people don't know. So watch this video till the end and I'm sure it will benefit you. So first point is, in C++ STL we have sort function which can sort in increasing and decreasing order. It's up to us what order we want to give. And second point is, not only integral but user defined data type can be sorted using this function. So I have these 4 different types of sorting, meaning we'll use the same sort function, but we will use different functions and different data types to actually have so many aspects of the same functions to be covered. And this is very important point. Oh, I just messed with the number here. So this should be 2, this is 3, and this is your 4. Yeah. So the second point is very important. Internally, it uses intro sort. This is really very important point. So many people don't know this. Let me explain this very quickly. Actually, whenever you do this sort, there is not only one sort function like quick sort or something underneath. No, there are different sorting algorithms, and what type of data you feed and what are the circumstances, it picks the right sorting algorithms and sort your data. So internally it uses intro sort. Intro sort is a combination of quick sort, heap sort, and insertion sort. So by default it uses quick sort, but if quick sort is doing unfair partitioning and taking more time than n log n time, it switches to the heap sort. And when the array size becomes really small, it switches to the insertion sort. So you can see that it uses quick sort, heap sort, and insertion sort. And quick sort can be used at the first time, but if it is not doing correct partitioning and the complexity is going more than n log n, it will switch to the heap sort. And if your array is literally very small, it will go ahead with the insertion sort. No need to create heap and all that.
So internally it does this checking. So many people don't know this. And the last point is we can use parallel execution policy for better performance. This, I bet, would blow your mind that you just have to pass only one parameter like this. You just have to say that sort this vector from this place to this place, meaning you have to give the start and end of the vector, and then say that I want to implement a parallel execution of this process, meaning how many cores you have, it will try to utilize that many cores. So this is the best part. You do not have to do any multi-threaded coding in order to achieve a very good result. It already is available. You just have to use it. Now there are some situation where you cannot use this. I mean, if you have data arrays or some things, because there are so many algorithms provided in your algorithm section of STL. So it's not like in all the algorithms you can do this parallel, but there are so many algorithms where you can do the parallel processing. So I'll create a separate video for this parallel processing. I will not talk about this parallel processing much, but I am bringing this parallel processing into this video so that people should be knowing if they want, they can use this parallel processing for sorting, and it will be really very fast. Right now I don't have much data. If you have so much of data, you can use it and you will be shocked by the result. Okay, so we are done with these points here. Let's look at the first type of sorting. I mean, you will use integral data type like 1, 2, 3, 4, 5, 6. What is this data type? So we have this vector here. It's very simple that you will say that, okay, sort, and you will pass the start and end, and it will sort this, and let's see the result. And I'll just simply compile it and execute it. See, it is saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, 10 is not there. Okay. So it is sorted. We have checked it. This is very trivial. This is very important. User defined data types, meaning you have some collection of your objects, and depending on something, on some parameter in your class, you want to sort all those objects in your array or vector or whatever. So how we'll do that? So let me just simply comment this and let's look at that. Hey guys, time for a quick pause, and what you're seeing right now is my Patreon page. So if you don't know what is Patreon, it's a crowdfunding website where you can support any content creator like me, and in return you get rewards. So if you join me, I can be your private tutor, or you just want to chat with me and ask your doubts, or maybe you just want to support me with very small amount and I'll still have something for you. So do visit my Patreon page and see if you like it. And if you want to discontinue anytime, you can do that. So if you have already visited my Patreon page, let's continue our video now. So this is your point, a user defined data type here. And see, I have just simply used this less than operator overloading facility because you know what? Sort is not doing anything. Sort is comparing one element with another element, right? So comparing meaning it is taking one element and using this less than operator, and after that it is using another element. So it's like A less than B, and that A is actually the object of this point and B is also the object of the point. So I have overloaded that operator so that once this sort function internally doing one object less than another object, that would internally call this function here. And the logic to sort I have used is like x and y should be added and checked whether the addition of both x and y is less than the addition of the x and y of another object. Meaning if this 1 and 2 is there and then 3 and 1. So addition of 1 and 2 will be 3 and 3 and 1 will be 4. So this is less than this. So this will come first. So let's run this and see the result if it is doing the same job here. So I'll compile this and execute this. Uh-oh, I just forgot to save this. Oh my God. Okay, compiled and execute this. Yeah, now see. Okay, 0, 1, 1, 2 and 3 ones. Because the addition of 0, 1 is 1. So this object should be first in the vector, whereas currently it is in the last position. But after sorting it has come to the first position. Okay, so this is how you will do it if you have some user defined data type. I mean, this is one of the way. So let's look at the third way. We have sort using the function object. Let's see how that look like. So this is one of the way. It is called using a function object. Its syntax is like this. You will use operator, this round brackets, and you'll pass this custom less as a pointer here. So it will try to call this with the round brackets like this. I just messed like this. Okay, so when it will call it with these round brackets, it will end up calling this one. So as you can see that here also we are doing the same thing, not doing anything extra here. Let me save this and execute this, compile. Okay, sorry, I just have to remove this. It was for the example. Save it, compile this, execute this, and see 1 2 3 4 5 8 9. So this is sorting using this function object. So let's quickly comment this and see the last one, which is about my favorite. I mean, I've been working on Angular, so now I use this lambda so much. So this is also one of the way you will directly inject the function itself where you was using this custom less object. Okay, so you can directly use that function body here. See, the signature is exactly same. See, integer a, b, and return a less than b. See, it's exactly the same. It's just that you are using a lambda expression, not anything else. And let's save this guy and compile and execute. See, this is also sorting it. So now you might be wondering how to sort it in descending order. I'll show you that. You just have to pass std greater integer this syntax. So this will tell that, okay, you are looking for a descending order sort. So let's compile this and execute this. See, it is in descending order sorted. And for ascending, it's optional, but you can give this less. So if you will give less here, meaning less than operator to be used for sorting, now it is ascending order sort. So less and greater. Just remember this much. So let me comment this and tell you one more thing, which is exactly what I said in the beginning. This execution and parallel. There are 4 types of execution strategy, which I will explain in some other videos. And if you can, you try this with so many data. I mean, you have to randomly generate so much of data and feed that data into your sorting algorithm and see what is the result. And let me know if you see so much big improvement. So we'll sum this video. Thanks for watching, guys. I'll see you in the next videos. Bye bye. Take care. Hello friends, this is Rupesh and I'm watching CVP Nuts video series on STL algorithm series, and this video is about is sort function provided into your STL algorithm. And I want to create this video for the sake of the completeness of this whole series, and few people might find this interesting. So the whole purpose of this video is check if the element in range, whatever the range we will give, are sorted or not. Meaning, see, you have this vector here and I'm sorting it. Just forget this greater for now. And yeah, one more thing, if you are watching this video, I would recommend please watch the previous video of this series, which is about STL sort. I explained this yesterday, before this video. So you should watch this video first and you should watch this one next to that. It will be very helpful because I have explained what are the different ways you can sort and what is the actual algorithm used into the sorting and how you will do the parallel execution. Okay, so I explained all these things in previous videos, so consider watching that first and then come back here. So we were talking about is sort function provided into your STL algorithm. So for that you need to first verify that okay, your data is sorted or not. So first I'm sorting this vector here with this sort function, and let's just print that. And this is the function. Is sort is a function available into this algorithm, and it will return true or false. So let's quickly print this. See, it is printing 1 2 3 4 5 till 9, and then this last one is meaning it is true, meaning this is actually sorted. So the default behavior, the default sort it is thinking is increasing order. Yes, obviously. That's why I have written non-decreasing order, meaning increasing order. So the default one is increasing order. Let me change that. I can give greater here and integer, that's it. And so many people were asking me in the comment that why I keep typing this std even if I have included this using namespace std. So it's kind of a habit because generally in our project we don't have this, so that's why I keep doing this std, but we don't have to do it if you have this one. And why I include this here, because I do not want to write std again and again, but I still end up doing it. So yeah, you don't need this. So greater meaning it is going to sort in descending order. And now we are going to check whether it is sorted or not. It will show you 0. Let me save this, compile this. Hey guys, time for a quick pause, and what you're seeing right now is my Patreon page. So if you don't know what is Patreon, it's a crowdfunding website where you can support any content creator like me, and in return you get rewards. So if you join me, I can be your private tutor, or you just want to chat with me and ask your doubts, or maybe you just want to support me with very small amount and I'll still have something for you. So do visit my Patreon page and see if you like it. And if you want to discontinue anytime, you can do that. So if you have already visited my Patreon page, let's continue our video now. And execute this. See, this time it is 0, meaning it is saying that it is not sorted, whereas it is actually sorted, but it is sorted in descending order. So how you will do that then just try this. We can give greater here, and that's it. Let's compile this, and this time this algorithm will see that, oh, I'm supposed to verify whether it is sorted in descending order or not. So see, it is giving 1, meaning it is true. So this is sorted in descending order. So this is a very common and very small job, but when you are using STL, then it's always good to use everything what is available in STL. Do not have to write your own for each or for loop so that you can verify that, okay, one element is always less than another element if it is coming after. You can do that just by using this isSort function. Now wait a minute, this is very trivial. I mean, you are using this integral types and we are able to do this very quickly. But what if it is a user defined data type? I have explained in this video, previous video, how you will do it. So you will exactly do the same thing. If you have user defined data type, you will overload this function, okay? And it will work for that. And I'm keeping this exercise for you guys. I'm not going to do this because it is not that logically great that we should talk about it. It's just that you should have this practice. Okay. So in previous video, I have already explained, if you want to apply the same knowledge, you can apply, meaning you can create that point class here and have different objects like we have here. See, we have 3 objects here, and then you can sort them, and after that you can write isSort function and actually see whether it is actually checking or not. So it's like a homework for you. So whatever we were able to do into this sort function, these different types, we can still do these things in this isSorted also. Because you know what, if you are actually checking one object is less than another object, then you have to support this user defined data type, right? So it is actually supporting, so don't worry about that. It's just that you have to do the practice. So by this, we'll complete here, and tomorrow we'll see partial sort. This is very important and very interesting. So keep watching, keep learning. Take care. Bye-bye. Hello friends, this is Rupesh and you're watching C Beginners video series on C++ STL Algorithm series, and this video is about is sorted until. And this video is not that complex video, but I have to give these videos because I am creating a full series on algorithm available in STL in C++. And it is always good if you know what is already available in C++ algorithm, so then you don't have to write your own stuff. So as the name says, is sorted until finds how many elements are actually sorted in given range. Meaning from first to last, whatever the range you are giving, including first, excluding last, how many numbers are sorted from first. So it's like you apply like is sorted until and you give the range. Here I'm giving from beginning to end, meaning I'm giving a full vector here. You can give any range, and by default it is increasing order sorting, ascending order sorting, and it returns the iterator, like till what it was able to find the numbers are in sorted order. And then I'm taking the difference and I will just print it. So wait a minute, I'll just simply execute this and we'll understand this whole thing a little better. So let's compile this and execute this. See, it is saying that only first number is the one which is sorted because we are taking the diff or the distance. So this is sorted, return the pointer which is pointing at 3. So the difference from 0 to 3 is 1. So that's why it is saying 1 here. Okay, we can see that because it is not in sorted order from here afterwards, because we are looking for the ascending order. So 3 is less than 4, then only one number is sorted. So this is how it means. So if you want a descending order sort, let's do that. So it will be 3 then. Let's simply compile and execute this. Yeah, see, it is 3 now. So it means 4, 3, 2. These 3 numbers are in sorted order but in descending order. If I will make this 6 as 1 and save it and compile it, this time it will get 4. Yeah, see, because we are looking for the descending one, and we are saying that from beginning to end, search from beginning and go till the end. But we can give any place. So let's give from beginning plus 1, meaning we will start from 3 now. So 3 to 1, we will get again 3. Let's compile this and execute this. This is a little weird. I don't know what it is. Oh my goodness. If I'm giving this range, then obviously I will be taking this also, right? Then wait a minute. I will compile this and see. Now it is 3. Yeah, sure. So I was making this range plus 1, but I just forgot to change this one. So obviously, if you're saying that my range is from this to this, then you have to take the distance also from here to here. Okay, so this video is not so complex, but you know that okay, there is something like this available in algorithms in STL. So thanks for watching, and maybe next video is not on STL algorithm. Next video I will give AVL tree, which is balanced binary search tree, and there I'll explain how to construct from the beginning, and if it is not balanced, then how to automatically balance it, because balancing is really very important topic and it is very easy. So till then, bye bye, take care. Hello friends, this is Rupesh and I'm watching CP Peanuts video series on STL algorithm series, and this video is about nth element. So we have seen so many videos about sorting and is sort and partial sort and all those things are there in this series, and this is nth element. So you might have heard find the kth largest number from the given array. For that matter, let's suppose this is the input array and I want the first largest number or first smallest number, meaning I want the smallest number among all these numbers. What if I'm saying I want second smallest number, that is going to be 3, correct? Third smallest number, that is going to be 4. So this algorithm actually does this. It will actually find the smallest by default. Largest we can apply like this. We can say that okay, please take greater, and that will work as a nth element and find the largest among all these things. So the default is smallest, and you can give this greater, then it will become the largest one. So let's try to understand how this whole thing is working. And there is little different than only finding that number, because it actually changes your array. So how it changes that, we'll talk about that. So nth element is a partial sorting algorithm that rearranges elements in first and last range. So this is the range. You have first and last. So if you see here, this is your nth element. We are giving the first here and the last here. So it needs range, right? I mean, if you have this vector, maybe you want to perform the operation between this and maybe this only, or maybe from here to till end. I mean, that depends upon your requirement, right? So you will give the range here, this square bracket meaning you are actually including first, and this round bracket meaning you are not including last one. So including first, excluding last. So this is how you give the range here. So it is saying that nth element is a partial sorting algorithm that rearranges elements in this range such that the element at the nth position is the one which should be at that position if we sort the list. Meaning you're saying that give me the sorted element, only single one, and you are asking for the position that I want. Let's suppose this particular position. It's like you are asking for this position, what would be the number if I would sort all the elements without sorting? So the second point is, it does not sort the list, just that all the elements which precede the nth elements are not greater than it, and all the elements after it are not less than it. Meaning, let's suppose I'm looking for this particular position. So this is 0, 1, 2 and 3. So if I'm looking for third position, let's write 0, 1, 2, 3 and let's start sorting them. So 2 will come first, then 3 and then 4. Okay, so this is your index and this is your value. So this is how a sorting would look like, correct? But if you are applying this nth element, it will give you the sorted element for that particular position. Meaning if you are asking for this third position, it will give you this 4 here for sure. Hey guys, time for a quick pause, and what you're seeing right now is my Patreon page. So if you don't know what is Patreon, it's a crowdfunding website where you can support any content creator like me, and in return you get rewards. So if you join me, I can be your private tutor, or you just want to chat with me and ask your doubts, or maybe you just want to support me with very small amount and I'll still have something for you. So do visit my Patreon page and see if you like it. And if you want to discontinue anytime, you can do that. So if you have already visited my Patreon page, let's continue our video now. So this is the only sure thing. Now, as it will change your whole array, the guaranteed portion is left of this 4, whatever the values will be less than this 4, and right hand side whatever those values will be greater than 4. And the another point is, nth element algorithm is implemented using intro sort. This is a combination. One is quick select, this is one algorithm, and median of medians algorithm. There are two algorithms combined together to actually find this nth element. So when I was explaining you STD sort, that time I told that there is this algorithm called intro sort, but here it is intro select. So now you know what is the algorithm working inside this function, nth element. So let's read a little bit about this. First is, quick select is used to find the kth smallest number in an unsorted array. This is used to do that. Median of median is a median selection algorithm for better pivot selection, mainly used in quick select. So this is mainly used in quick select only to actually find better pivot selection. So if you don't know how this algorithm works, don't worry, that's not the part here. I have noted down this and I'll give video on this in future. So let's see how this one is working. So as I said, we have first and the last. So this is the place for first and comma, and this is where you will give your n, and here is the last one. So if you see here, v.begin plus v.size divided by 2. So whatever the size is divided by 2 would be half of it. So I am looking for actually the median. So can you see this? I'm looking for median here. So the size of this one would be 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 divided by 2 will be 4. So 0, 1, 2, 3, 4. We are looking for fourth position, which is this 5. Meaning we should get 5 when I will execute this. So this one should give 5. And then I have taken another example here. See, it's the same thing. Start and then the nth position and then the last position. But comma, I am saying that greater here. Meaning this time I do not want smallest. I want largest, meaning second largest. Here I am giving second position, right? 0 is the first position and this plus 1 will become second position. So second largest number. So this time it should give second largest, which is 7 here, I guess. Yes, 7. So we should get 7 here. Let's execute this and sum this video. Let's execute this. See, yeah, got it. See, the median is 5 and the second largest element is 7 here. So whatever I said is correct. This is a very cool function, right? This nth element, because now you do not have to write your own algorithm or write your own function which will give you this. You can directly get it and you have so many facilities. Like you can have this algorithm for integral data type, which is very basic one. And you can use a user defined data types like classes and all. You can use function object. I have given these 4 examples in sorting video. If you do not know what I'm talking here, you can go and watch this STD sort video of mine, you will get it. And lastly, you can use lambda expression to actually sort or actually differentiate between the elements of your vector if it is not numeric vector. So thanks for watching, guys. I will see you in the next videos. Bye bye, take care. Hello friends, this is Rupesh and I'm watching CPP Nuts video series on STL algorithm, and this video is about partial sort. So before this video we have covered STL introduction and sorting and is sort function of algorithm, and this video is the fourth one in this series. So I would recommend please watch those videos first so that you will get the idea, or at least you should watch, and at least you should watch sorting, because I have talked about this algorithm little more, like how the algorithm actually work and what are the parameters you pass, so you will get more idea. So let's talk about this partial sort algorithm. This is a simple algorithm. It takes a range. See, if you take this partial sort here, it takes a range, but it has little different syntax than the previous one, which is sort. So the idea is like this. There are three parameters. There are actually more than three parameters, but I will show you those parameters a little later. So consider there are three parameters, and you are saying that I would consider it from beginning to end. Now this middle argument is a middle argument which will tell that from beginning to the middle one. So currently I am pointing at beginning plus 4, meaning 0, 1, 2, 3, 4. So I'm pointing at this 8 right now here with this one. So it's like we are saying that, dude, cover whole array, I mean vector, but sort from beginning to the middle one. And the range is like this, from first to middle. And these bracket, this is square bracket and this is round bracket. And here square bracket meaning we are including first, and round bracket meaning we are excluding the middle one. So if you are saying that, dude, sort my vector and consider whole vector, but sort only from this place to this place, because you have given middle as 8. So it will only sort this much place, but it will consider whole array, meaning it will find the correct placeholder in whole vector. Okay, I'll show you the result here. Let me compile this and execute this. See what it is doing. It is sorting these 4 places only. So we ask that you can look for the better elements in whole vector. That's why it brought this 0 in the first, and then 1 here as first, I mean second, 2 and 3. So now you might be wondering that why this 8, 7, 6, 9, 5, 0 is in this order. So the order is undefined. Once you do the sorting, meaning you are saying that from beginning to middle you sort excluding the middle one, then the rest elements position will be undefined. So you cannot say that, okay, 5 is coming from here to here, then it will come to some specific place. No, that order is not defined. So let's look at these nodes so it will be very clear. So the partial sort rearrange the elements such that the range first and middle excluding middle contains the sorted element. So see, 0 is considered for first because I have said that consider from beginning to end. See, from beginning to end. What if I do not want to take this 0? Let me decrement it. Let's save this, compile this and execute this. See, this time it is not taking this one. See, this time this 0 is here only, and 1, 2, 4, 5 have come. Before it was coming here. I mean this 0 was coming here. Okay. Hey guys, time for a quick pause, and what you're seeing right now is my Patreon page. So if you don't know what is Patreon, it's a crowdfunding website where you can support any content creator like me, and in return you get rewards. So if you join me, I can be your private tutor, or you just want to chat with me and ask your doubts, or maybe you just want to support me with very small amount and I'll still have something for you. So do visit my Patreon page and see if you like it. And if you want to discontinue anytime, you can do that. So if you have already visited my Patreon page, let's continue our video now. So if you see this cppreference.com, you can see these many overloads are available for this particular functions. So I'm particularly interested in this last one, which is saying that you can have the first element as the execution policy. So if you are watching my series, I have already talked about this execution policy. You can run this algorithm in parallel if you want to, and your data supports that. Then you can
use execution policy, and then the first element and middle element and the last element. And after that we have this compare function, and the by default sort is obviously increasing order sorting. We can do this greater integer and this. So if I'll say this, let's compile this and execute this. See, now it is decreasing order. See, 8, 7 and 6. So these three positions are sorted but in decreasing order. Okay. So we did not complete these nodes here. The order of equal element is not guaranteed to be preserved. Meaning, if there are a similar element, like there are 2, 3 zeros here and they are placed here and there, then the order of those zeros are not fixed. Meaning, I can pick this 0, if it is here, I can place it somewhere, or I can pick this 0 and place there. It's not fixed that I will take which 0. So if there are multiple duplicate elements, there is no guarantee. And the another point is the order of remaining element is unspecified. That's what I tell. If you are sorting this much only, then whatever the other elements are, their position is not defined. And don't be confused with the sorting here, because in sorting also we give range like begin to end, remember? But that sorting is different. There you will sort whatever the range is given, you will sort everything. But here we have this middle concept also. Okay, so don't get confused with that. So with this, I'll conclude this video. Thanks for watching, guys. I will see you in the next videos. Bye bye. Take care.
Hello friends, this is Rupesh and I'm watching CVP Nerds video series on STL, and this video is about STD pair. So if you're looking for a programming channel where you can learn data structure, algorithms, design patterns, threading and whatnot, then so do consider subscribing this channel because I upload these videos almost daily. So let's move to this topic. So the STD pair. Have you ever thought of, dude, I want two values to be combined together. Oh, it's looking like my symbol, right? Okay, let me just draw this. Oh yeah. Okay, enough. So the question is, do you ever feel that, okay, man, I have two values. They can be just simple name and the age. So it's like only one object containing name and age both. Then this is the answer for your problem. Actually, this is how the syntax look like. You have this pair data type. T1 and T2 are different heterogeneous. I mean, it can be any type. It doesn't need to be same. You can put actually any type of data together. Yeah, nice, right? So let's move to this node. STD pair is a struct template that provides a way to store two heterogeneous objects as a single unit. That's what I said here. We have single unit. Inside that, we have two data. Sometimes it happens that there is some function, and from that function you want to return two data, and now you feel that, okay, I have to create a structure or something to return it. No, you can return the pair. You have the solution already, and we will see different use. But before that, map, multimap, unordered multimap can use pair to insert data into their structures. So even these data structures uses pair to insert data in their own data structure. So pair is not just simple data structure. I mean, it's really very good because it gives you this facility. So let's go ahead, and this is one way of using it. Like you can have STD pair integer and integer. So I'm initializing first and second. So this is your first data type, this is your second data type. So this is the first value, this is second value. So now if you will send this to print, this is the function, we'll take this inside this object, then object dot first will actually print 10 and this will print 20. So this will be first and this is going to be dot second. This is how you access the elements inside this pair. And yeah, again, it can be any type, not only integer. I have shown here that you have this pair of string and unsigned integer. You can even have pair of integer. You can have, a vector here and another vector here, map here, another map here, or whatnot. So if you have two data, you can package them into one. Okay, so this is one of the way, and another way is this non-member function can be used to actually create the pair. So this will also create the pair for you. And I have shown this example. I have a list which is vector of pair of two data type, string and unsigned integer. So string will hold the name and unsigned integer will hold age. So I have made 4 entries inside this and I'm printing it here. So let's see this program, how it works. So let's compile this. Okay, compiled. And if we'll execute this, see, the output for this guy is 10 and 20, and same for this guy, it is 10 and 20 because we are doing the same thing here. And this is how this guy is working. We have vector which takes data type as this guy. So what we are doing, yeah, this is very important. See, we have the list and here I am using make pair function, which is this one, to create my pair and insert that or push back into this list because it is a vector. And here if you see, I'm using pair, but explicitly I'm defining the type, that what is going to be the type of my data, what I'm going to insert into this list. But actually it is not needed. Now we have automatic type deduction and this guy will also work. And at last I'm just iterating over this list and we're just simply printing it. So as I said, if you have 2 data and you want to combine them, you should use pair, or there is another thing called tuple. You can use that also, okay? So thanks for watching guys, and don't forget to hit the like button guys. And if you're new to this channel, do subscribe and don't forget to press that bell icon. This is how it looks like, okay? Just press it so you'll get the notification for upcoming videos like this. I'll see you in the next videos guys. Take care. Bye bye.
Hello friends, this is Rupesh and I'm watching CPP Nuts video series on STL Algorithm series, and this video is about std iota. So with the help of this function, you can put data incrementally into your containers. So this is how it works. So if you see here, you have list, you can have vector, array and stuff, then you give the size. So this list is having 10 size, and if you say that iota begin to end of the same list and you assign some number, you can say from 0. So from 0 to 9, meaning total 10 size will go into this list, and if I will print it, it will go from 0 to 9. And not only number, if you concentrate here, what I'm doing, I'm creating a vector of size, whatever the size this list have, meaning it is 10. So vector is going to have 10 size, but the type is this, meaning it is going to store iterators of list for 10 times. And if I apply the same iota function and say that vector begin to vector end, and this time take list begin, meaning start from this one. And if I will iterate over the vector, you will get the same result what you had here. So let me compile this. If I'll execute this, this is how the result would look like. So 0 to 9 is for this for loop, the first one, and then after that 0 to 9, as you can see here, is for this for loop. So if I will give -5 here, let's do that, -5. So -5 is the initial value, then it will start decrementing it, will start incrementing, then it will become -4, -3, -1, 0, 1, 2, 3, 4, something like this. So let's compile this again and execute this. See, -5, 4, 3, 2, -1, and then till 4, it was initialized into this list. And then this vector is constructed, and we are saying that we want to point out the iterator of this list. So this is how it will work. So now we are having vector filled with the same values. And actually this vector is pointing to the iterators of this list only. Okay. So whatever this list is having, this vector will point to that one only. So that's why it is repeated. -4, 3, 2, 1, 2, 0, 1, 2, 3, 4. So same will come here. So this is actually very good function if you want to populate some data into your vector, list, array. You will just simply do this and you will give the start of that value. It will keep on incrementing and the push will happen. So let's read this. Fills the range, whatever the range you give, including first, excluding last, with sequentially increasing values, and starting with the value and repetitively evaluate plus value. So here I have given -1, so plus will become 4, -4, then -3, -2, -1, 0, 1, 2, 3, 4, like this. So now if you need sequential data in your container, you can have it with this iota function.
So with this, I'll conclude this video. Thanks for watching, guys. Keep learning. Be safe. So till next video, bye bye. Take care.